Anybody there? Does anybody want to learn amp repair? Got any more of them amps to fix? Well, it's a bloody good job I got a pile of trashers sitting next to me right now, isn't it? Look at this bullshit. Look at this nonsense. Look at this rubbish. Freaking... Look at this stanky ass unfinished missing parts boards. We got some rubbish on the bench, which always makes for a fun stream, because rubbish on the bench is not stuff that belongs to customers, it belongs to me. So as a result, we can be a little bit funky and a little bit interesting and entertaining with the repair procedure. Good evening, gents, and any ladies that might be present. I am just about to turn my microphone down because when I was doing the mic test earlier, I was doing the mic check 1 2 1 2. I was talking much quieter than I am now. I realise I speak much louder when I'm actually streaming compared to when I'm mic testing, so minus 8 dB should be about right. Yes, my boys, how's it going? How's it going? What have you guys been up to? It's been not too long since my last live stream, and if I'm honest, I haven't really got like a massive whole big plan for this evening. I just kind of fancy doing a stream. Kind of feeling a bit lonely up here after moving house, new location, don't fucking know anyone up here, so I just thought it'd be great to kind of hang out with the boys. And girl, I think there's one girl that's ever watched my live streams. Jesse, you know where you are if you're there. So yes, how's it going, guys? Let's do some nice chatting this evening. What are we fixing? Some nonsense this evening. Got some Lanzar. What even is this one? This is a Power Acoustic. Lanzar and Power Acoustic, your two favourite brands, the two world record setting brands in the nationals, in the finals. Yeah, Lanzar was taking first place. Power Acoustics coming in sweet with a second place, 0.2 dB off. Clamping a whopping 712 watts RMS at 4 ohm bridged, my friends. Bro, what's your input on the DS18 EXL SQ 1000.4? Now, I haven't seen that amplifier on the bench. I haven't even seen gut pictures of that amplifier, but I can tell you now that DS18, they don't actually R&D any of their stuff. All of DS18 is just like your cookie cutter generic kind of circuits off Alibaba or off the Chinese factory. So the 1000.4 is going to be a Class D full range probably, and the SQ it's probably not going to be very SQ-ish. Yeah, they're going to be quite noisy, high noise floor. And they are going to not have particularly nice clarity and detail in the high end because the switching frequency isn't very high. They're going to be very sensitive to problems like running under impedance and stuff like that. Very delicate, so treat it easy. But they are a great way to get super loud doors from a not very big footprint. That's a small glass of vino. Well, it's a good job, but I can keep topping this small glass of vino up. You know what? Yeah, I just moved into this new place and I've only got 3 now wine glasses, and these are the ones that were kind of just in my little pack of stuff that I was bringing up to the new place, and they are very small, I have to say. But you know what? I actually prefer a small glass of wine because it tends to stay cool if you're having white wine, of course. Never ever drink red wine cold. Who are you? Who even are you? Don't even ever do that. If you drink red wine cold, then actually you can stick around because we're all learning amp repair. I don't care, but don't do that. But yes, white wine, it stays cooler longer in the bottle because there is more mass, more thermal mass is staying together in a group more, so it takes longer to heat up if it's staying in the bottle. So a smaller glass actually keeps your wine cooler for longer. Anyway, what were you saying? What would you say is the best 5K amp to buy right now? If hippopotamus, if you can get your fat ass, if you can get your fat hands. What do hippopotamuses have? They don't even have hands. They have not paws. What do the hippopotamus have on its like what's that bit called? I guess it's a foot. If you can get your feet on a Paris 5K or even the 8K because they're pretty cheap, that would probably be the best bass amplifier on the market right now. When you look at how much it costs versus what you get, they are phenomenal amplifiers, super awesome circuit design, fantastic serviceability, amazing build quality, and they are super cheap. Like, they're really, really affordable. Like, there's nothing to not like. So if you can get your hands on them, absolutely smashing. Optimized logic repair. Sadly, I know a lot of people drink it with ice. Bruv! Although, I haven't tried it. You know, they always say, don't knock it till you tried it. I have never tried red wine chilled, because that goes against my, like, my DNA, you know? Like, freaking, I would just shrivel up into a ball. But maybe it's alright. Maybe if it's a super stanky hot day outside, and you're feeling the sweat dripping off, like, steaming away, and you want some red wine, because, you know, you're having some nice meal that goes well with a red wine, and you're like, man, it's so freaking hot, I want a refreshing cold ass drink, and you literally don't have any white wine, or you don't want to have white wine, and the red wine, you're thinking, well, I'll just put some ice in there. Nice. Goes well, but I think it ruins the taste, personally. Anyway, on the bench, I've got something weird on the bench. Where the hell is my hat cam? Oh, here we go. So, what's this? This is not an amplifier. I was just test fitting, doing a little test assembly. I've got these motors laying around. Got some Neo motors just laying around, just kind of casually chilling on the back burner on the bench over there. Yeah, these are the Neo motors that you might have seen in one of my videos on YouTube. I did a video that was like with showing off a couple of Z. If you're from the UK or Canada or Australia, I think you say Z, but everyone else says Z. I was showing off some Neo motors that I had years ago on my channel. I had a pair of 18s, a pair of blue carbon 18s, and we were showing off some Frio excursion on the videos, and these are those same motors. I did actually sell those woofers. Those 18-inch woofers were assembled for a customer. Then he wanted something different, and I took them back in a part exchange, because I was actually planning on using these for something of my own. I was like, oh hell, I could do a part exchange. It was a great deal for me, because I part exchange less value for what I originally sold them for, so it was a good deal for me to part exchange them, and then he went for something more bigger, and so basically I took these back in part exchange. I was going to use them, and then I changed my mind, didn't end up using them, got some Z4s in the van anyway, so I just basically been trying to sell these and haven't been unable to sell the motors alone. So I picked up some soft parts that one of my business partners had laying around. He had some old 10-inch baskets laying around. Oh crap, that's not attached. With 10-inch baskets, old fashioned style, with a 7.5-inch spider landing. Small 10-inch cone, and basically I'm just going to get some nice coil and spider for this. I'm going to assemble it up into a pair of 10s. I've got another one sitting down there somewhere. So we're going to make a pair of old school style DDZ 10s, but these are not actual DDZ motors. These are not real. We had these made. My business partner actually had these assembled to DDZ3 spec at the time, and we even did the curved Neo slug, the curved face on the Neo slug. That was the thing that differentiated the Z motor with all the other Neos on the market at the time. We had it was N52 grade Neo, very freaking expensive, absolute cost a bomb to have these assembled, with the curved edge on the Neo there, shorting ring, and these are actually pretty lightweight. I mean, they still weigh a fair bit, but they're actually lighter than the standard Z motor. And an interchangeable top plate, and yeah, I'm gonna build them up as some 10s, and maybe someone will do some crazy kind of compact build with a bunch of power, small enclosure. What happened to your D Audio 12 custom enclosure? No, that was for a customer, so that's last time I was aware that was still in his car, still using that. Yeah, for sure. Anyway, so that's what's on the bench right now, but we're going to move that off the bench because we are going to take a look at some stanky piece of chocolate finger. We're going to take a look at some stanky amplifiers that I've got here that have just been on the back burner as like parts amps for a while now. But I thought, you know what, I haven't actually nicked that many parts from them, and it'd be cool to have an amplifier that works sitting around that I can run tests with and stuff like that. So let's put this down to one side. Yeah. Got to put this somewhere where it's not going to get attached to everything. And unfortunately, I'm kind of tethered to my seat now with this hat cam. Yeah. There's some old man noises for you. When you go past a certain age, whenever you do anything strenuous, like getting up from a chair, getting up in the morning from bed, getting up off the toilet, it's mandatory when you're past a certain age to make some noises that are like mandatory old man noises, guys, past a certain age. Alright, what we got first? This looks pretty interesting. This is a power acoustic. Now, hey, this actually isn't such a bad circuit. Let me get this camera light leveled up. Let's get there. There we go. Keep that nice and central park. This actually, get rid of that. I don't even know what that phone number is. That's fucking probably years old now. Power acoustic are pretty shit, but this circuit design isn't actually too bad. This is a very similar circuit design that you'll find in some Sundown amplifiers. There's some of the Sundown, I think they're SAX or SAE, one of those ones. This circuit design, almost exact same circuit you will find in some of those amplifiers. And this thing looks pretty beefy. I mean, I'm not gonna lie. This isn't like a really small circuit. It's quite well assembled as well. Power acoustic have made some shit over the years, but this one is, I mean, it's gonna do some power for sure. It's not going to make the power that it says on the case. What does it say? It says 5,500, 5,500 watts. 5,500 watts. Well, it's definitely going to make that much power, but it's probably going to make a solid like 2.5K looking at this thing. So I thought it'd be pretty interesting to see if we can get up and running, see if we can find out what the hell the problem with it is. It's probably got a whole bunch of problems. It's been sitting dusty on the back burner for like years. But I thought it could be fun to go through, see what it's doing, see what it's saying, because this is a pretty common generic circuit. So if any of you are actually doing amplifier repair yourself and you're not just watching it for the lulz, and because you've got nothing else better to do, then it might actually be interesting for you and somewhat educational. If you find Portuguese, rosé or green wine, you'll never drink white wine again. Maybe you can find it in the UK. Hopefully it's different to normal rosé wine. Rosé is not a particularly nice drink, I don't think. I really enjoy. Kind of tastes like socks, like stanky socks you've been wearing all day. Green wine, not heard of green wine. That sounds interesting, man. I might have to check that out. Not seen it in the UK, I have to say. So the circuit design on this bad boy is, let's get it zoomed in, we can have a cheeky look. So power supply, where is the power supply circuit? Actually, wait, where the freaking, it's over here. I think I need to get some more light on this. There we go. So this is the power supply. This is the power supply drive circuit, and what we have here is we have a SG3525. This is the PWM controller. This is what generates the pulses for the power supply MOSFETs to run. It also controls protection circuit, and I think that's it's a pretty cool little chip. It has quite a lot of functionality. You can customize it and program it a lot easier and a lot more in depth than you can the 494. Majority of the time you'll see like more premium amps using the SG3525, which is funny because this is a power acoustic. So when I say that this circuit design has been used by other brands, including Sundown, on some of their nice amplifiers, this actually isn't such a bad circuit design. This layout is quite nice. It's simplistic, more modern than some others. And it just works. It works. Well, this one obviously doesn't work at the moment, which is why it's here. But it generally works pretty nicely. So yeah, 3525 is used there. We've got our power supply drivers here. Surface mount. Not always a big fan of surface mounts because when they burn, they freaking cook up and destroy the board. Some more protection circuit stuff over here with a comparator. And if we take a look over here, we have the auxiliary voltage regulation circuit. So we've got to get a, is that a 7812? That is a, oh, that's a TIP 41C. So they're using these transistors. Yeah, they're using these transistors as kind of programmable regulators. So not using a voltage regulator IC, using transistors and probably some xenodiodes, or just voltage references and stuff based on resistors to step voltage down for plus minus 15 volts. And so this is probably plus minus 15 volts for these TIPs, and then this one here is probably going to be your 12 volts reference negative rail. That is an LM337, but we shall find out when we get it powered up. Over here we have the rectifiers. There are only 2 rectifiers on the board by the looks of it, and they are random. We have one rectifier is the lighting is terrible this evening, I'm not sure why. One rectifier is a MOSFET 30D20. Now these are pretty naff parts. I'm not a huge fan of these. And this one randomly has been like subbed in. This is an F60 UA60DN. That looks like it's going to be overkill for the circuit. Like that suggests that this is a 60 amp 600 volt part or something like that. So not seen that one before, but that obviously this amp has had random parts removed and replaced before. I imagine it's probably fine though. Rectifier diodes, the rectifiers and the amplifiers, they're not. It's not too critical. Because the voltage across these is pretty high. Because you've got high voltage going across them, and it's just a rectifier diode. It's nothing complicated. It's not like a MOSFET or anything like that. You find that they can pass like decent amounts of power. You'll find what is it in the case of like the some of the big 8K amplifiers, you might have 32 output MOSFETs, but you might only have like 8 rectifiers, and when you look at it in your head, you're thinking, well, why does it need 32 MOSFETs that are actually passing the power on? But the power has to make its way through the rectifiers. How can it make its way through 8 rectifiers, and it needs all those power supply FETs and all those output FETs? Well, yeah, the rectifiers actually are freaking beefy as who, yeah, they're not as complicated, and you don't need as many of them. So that's that is the rectifier section on this one. The power supply over here, we have 6 MOSFETs in the power supply. We have 3 transformers. Each transformer has a single push-pull MOSFET over here with some smoothing capacitors right up next to the transformers. The transformers are seated down real nicely. To be honest, like, this is not going to suffer from vibration damage whatsoever, even if you mount it to the box. This is really well seated down, really good build quality in this. Output inductors also really well seated down. Shouldn't really, I mean, yeah, there's a chance that that's going to suffer from some vibration damage there. The hell's going on with these pedals? There we go. Like, yeah, that could definitely rub and short, so that's not the best. But the power supply transformers are much better on this. Got a couple of big beefy relays right here on the outputs. This is overkill. You don't need that many relays. I think is this even? This might even be. No, I was thinking that might be full bridge, but it's not. Because usually, if you see 2 relays like this, then that might suggest that there is actually a sine wave on positive and a sine wave on negative. That is overkill. Definitely that was not needed. They could have got away with just having 1 relay on this. Output MOSFETs then. We have all the output MOSFETs fitted, which is strange. This amplifier, I have no idea what's wrong with it. I don't know why it's here. It's just been on my back bench as like a spares parts amplifier for ages. We have IRFP 264s. I think from memory these are 200 volt parts, and I think they're pretty beefy. Don't use IRFP 264s that often. I see 260s quite a lot. They're pretty beefy, 200 volt parts. The 264s, it's not so common. On the amplifier we have quite a few fuses. We've got 1, 2, 3, 4, 5 40 amp fuses, which, judging by my maths, is 20, 30, 4, 8, 12, 16, it's 200 amps. So 200 amps, yeah, we should see around about 2,000 watts, 2,000 to 2,500 watts RMS from this amplifier, which is not too bad. Output drive circuit then. we have over here. Now this is pretty modern, simple, basic little output drive circuit, and you can see on this board they've actually like kind of outlined each individual circuit. You see this is output drive circuit, this is power supply PWM circuit, this is protection circuit. They've like drawn it out nice and easy for you to see what part's what, which is kind of cool. And you can actually see, actually, hey, this is hilarious actually, because look, see this little square, okay, this little square, this would normally be an external driver board. See these holes here, these pads, these are for headers, these are for the pins. So this would usually be a separate driver board that would sit in the PCB, like on top of it in headers. This driver board, actually this exact driver board, is used in amplifiers such as the Orion HCCA, the new big red ones, the B2, crap, what ones is the B? Yeah, some of the B2s use it as well. What other ones have I seen use that? I can't think off the top of my head now. Is it Precision Power PPI 10K used this driver card as well. So yeah, quite a few like decent, somewhat reputable brands using these drive circuits. So yeah, from Power Acoustics, you would think it's a pretty shitty brand, but actually this circuit design is not too bad. Looks like a new Orion XTR. Yes, actually Orion XTR. That is another amplifier that uses this same drive circuit. Hey Tom, still got your landline phone? No, I don't have my landline phone anymore, my friend. If you were watching the streamers live stream, you'll understand that joke. I don't actually have a landline anymore in this property, so. Andrew G says, I have a Sound Digital 8.8K power amp wired to 1 ohm. I want to buy a third 9900DD unit for sure. Oh, sure. If it will be okay at 0.66 ohm, what do you recommend, or leave it at 1 ohm? No, I would leave it at 1 ohm. Those Sound Digital amplifiers, they're very good for the price, but there's not a lot of headroom built into that circuit for the kind of low impedance running that your impedance rise might bring it back over 1 ohm for the majority of the time, but those amplifiers are kind of built and designed with impedance rise in mind. Like if you run those amplifiers into a static load or into a true 1 ohm load for a long duration, they do overheat and they don't like it. So I would advise not doing that. If you want to add another 9900DD, then I would recommend looking at a different amplifier. Maybe getting a PowerOS 0.5 ohm version or a Taramps 0.5 ohm version, and then running it at 0.66. That would be a really safe option. You can get like a big ass fucking 15K or something like that. That would be pretty awesome. Anyway, so what's actually wrong with this then? Why is this on my bench? Well, let's take a little sneaky peek with my brand new multimeter, which I actually don't particularly like. I've been using one of those cheap ass, well this is still kind of cheap ass multimeter, but I've been using one of those kind of Walmart style. It was a laser branded multimeter. I've actually got it in here because it is fucked. I popped it. I popped it. I was using this multimeter for like years, you've seen in my channel, but unfortunately I did popped it. I popped my multimeter, which I was really pissed off about. What I tried to do is I tried to hook up, I was bored of changing batteries, so I tried to just hook up a little 9-volt power adapter to the battery wires here, so I could have my multimeter on permanent live from the mains, which should have worked fine, except unfortunately, my power adapter for 9 volts decided to malfunction at the time that I turned it on, and instead of sending 9 volts, it sent like 24 volts and fried the actual PIC, fried the actual, you know, the chip with the brains that runs this thing. So unfortunately, it's dead now. So I have a new multimeter. But you know what? I really don't like. Everyone was saying to me, "Ah, get a fluke multimeter, hey, fluke tree." I'm not a fan. I'm not a fan of auto-range multimeters. I'm not a fan of auto-range multimeters because with an auto-range multimeter, you put your probes on there. It takes a minute to think about it, and then it kind of knocks through the ranges like an automatic going through the gears slowly, and then gives you a value. And the number on the screen, you can't immediately look at the number and be like, "Ah, that's that." You have to look at the number, and then you have to look at the tiny little symbol, whether it's mega, milli, killer, whatever it is that it's next to work out what you're reading. Now, I don't want that. What I want to do is I want to be able to tell my multimeter, right, I am expecting this part to read in the 200 kilo ohm range, okay? And then if I put my probes on the thing and I see a number on there that's like 76, then I know instantly, right away, that's 76 kilo ohms. However, if I'm expecting to see like 120 kilo ohms and I put my multimeter probes on here and it just shows 1 like this, it just shows 1 on the screen, then I know that there's something not right there, that there's a part that's potentially failed or something. Or if I'm expecting to see, I don't know, like freaking, if I'm expecting to see 20 ohms and I put my probes on here and I see 200 or like 150 or something, then I know there's something wrong instantly, because I know what to expect, and then the number that it's telling me, I just much prefer having a manual range. I don't like the auto range. They're slow, they're laggy. It takes me a while to be like, oh, was that milli mega? Like, no, I don't like it. Also, another thing that I don't like about the flukes and stuff in the auto ranges is there's a delay. There's a delay on the beep, on the continuity mode. This one I made sure, because I asked the seller before I bought it, is there any delay between touching the probes and hearing an audible beep from the continuity test? And he was like, no. I was like, it's perfect. It is instantaneous, which is what I've got used to with my old multimeter, and is what I need. I used some other guy's fluke a while ago, and it wasn't instant. There was a small delay between touching the probes and hearing the audible beep for the continuity. It drove me mad. Could not use it. Absolute rubbish. Don't like it. Yeah, I just want a nice simple multimeter that I just flick it to whatever I want it on and then read it, and it's instant. So let's go through this board and see if we've got any dead parts. So the power supply usually would burn up, like visibly burn up if there was a problem. We just check continuity across the power terminals here. We'll tell us if there's any dead power supply FETs. As you can see, I've got the screen up in the corner now, multimeter cam. So you can see there that there is no continuity. We're just charging the capacitors backwards, and that's fine. So the power supply is probably going to be working fine. Output section. Just going to check to see if we've got any shorts or anything on the outputs. No, seems alright. Alright, interesting. This might be a pretty fun repair then, because if this is here with me, then it must not work by default. Surely it must not work. But we don't have any dead output FETs. We don't have any dead power supply FETs. The rectifiers are interesting to say the least, but they're there. They're not shorted. Regulator circuit. No shorts there. So that's going to be potentially an interesting repair. I think we might turn this on and we might find that there is no output switching or something like that, or it draws excessive current. So this could be a good one, guys. Let's have a look. Let's plug her in and see what we find. Where's my hammer? I'll probably be quoting a lot of photonic induction in this live stream, because he's back. If you didn't already know, if you don't know who he is, then man, what are you doing here? Get to know. Photonic induction was one of the very, 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 very first YouTube channels that I stumbled across back when YouTube was freshly newborn, like 2006 vibes, 2006 to 2010 kind of vibes. And photonic induction, if you go on his channel now and you go back to the oldest video on his channel is actually a reintroduction. It's like, I'm back, and I think the date on it's like, I don't know, 2000, fuck, I don't know, it's like, it's not even that old. It's like, it's not even as old as it should be. His channel, the videos all disappeared for ages, and then he came back. But that video is so old that you can't believe that the first video on his channel is not actually the first video on his channel. It was like a comeback video from way back in the day. His channel goes so far back to the very, very beginnings of YouTube, and he disappeared for a long time. Had a lot of personal life issues. He wasn't making videos for probably he wasn't making consistent videos for probably over like 5 or 6 years now, maybe even longer. And lots of now big famous YouTube channels like Hedonic Plus channel and BigClive.com and stuff like that. They all used to watch photonic induction like way back before their channels were even a thing. and you can see on his now modern return video, and he was like, "I'm back, guys. What's going on? Making videos." You see the comments are just so many are from verified channels, like of people that used to watch him, like that are now doing their own channels, possibly as a result, you know, kickstarted off the back of him. So massive respect for Andy at Photonic Induction. Love his stuff. Go watch his channel. It's amazing. And it's very dated. It's very, in a good way. It's like kind of old school style YouTube videos. You know, no fancy editing. It's all, it looks like it's been edited in Windows Movie Maker from like 2008 or something. It's like, it's good vibes. Jesse, how's it going? I was actually talking about you like right at the start of the stream. Optimized says, not sure what fluke you're talking about, but my 87V is instant. Good to know that there are some ones that are instant. I have no idea what fluke this guy's was. I think I was like diagnosing some issue. He brought his car around and he's having some problems or something, and he brought his multimeter with him, and I was just kind of using that one because it was with him in the car. And I think I was trying to test for continuity between all of his RCAs and wiring and stuff like that, and it was just driving me nuts that there was like a decent delay between touching on continuity and the beep coming, and I was like, I can't deal with it. Yes, Photon's a legend. The 5,000 amp guy. Man, have you seen the amount of views his new videos again? I am so happy for him. I'm so happy for him. Literally, he made a comeback, and I don't think he was expecting it to be as big as it. Like, I thought that I think he thought that he would like make the comeback video, maybe get like a couple of thousand views or something, some like people that remembered him from back in the day, and it was going to go really slowly and take off slowly again. He was just going to do it for fun, but no, my god, his new video, like the first new video, proper video they put out, which is a 5,000 amp breaker pop, that video in like 2 days was over 2 million views. I was like, what the fuck, man? Absolute madness. Was that a train? Yes, it was. I've got my window wide open because it's roasting as freaking hell, and it's like stuffy, hot, sticky, nasty weather. Yeah, there's actually a train line that runs not too far to the back of the property, which I don't care about, you know. I quite like it. I don't mind it at all. Some high voltage out there, you know. If I ever get in a sticky situation, need some high voltage, just fucking get a fishing line, ping onto the old train wire like they do in Brazil for the car shows. They hook it up to the power lines, and yeah, I got myself some 450 volts. I think it's 450 that uses out there, the train line. Per says, sorry, excuse my nasal issues this evening. Have you got 20 seconds to answer that question for me? I've got a DD M4A on a pair of ZV5 15s, and I can't seem to set gain to its max potential. Try to set this go. What do you mean, my friend? Can't seem to set it to max potential. Explain what you mean. Do you mean that you're turning the gain up and you're not finding the clip point, or you're finding the clip point but it's just not loud? Like, what do you mean, buddy? You said you've tried oscilloscope, digital multimeter, DD1. So you've tried the kind of posh boy, fancy, official certified methods, which is fine, and they work, but they only work really kind of provided you take their readings with a pinch of salt, because they're on paper correct, but it doesn't always work out in the real world for getting the most out of your system. You end up leaving a lot of performance on the table. It never clips. So if it never clips, my friend, so sounds like so you can have your gain fully maxed out and you're not getting a clipped sine wave on the oscilloscope, and your DD1 is not showing the distortion. Is that correct? That would only really happen if you're feeding that amplifier with a really low, like a stupidly low input signal. Most of these car amplifiers, they will push their output sine wave to clip point if they're given anything more than a 0.2 volt sine wave on the input, on the RCAs. Yeah, you'll see that on some amplifiers. I might even say it on this. No, who am I kidding? The Lanzar would never say that. It just says min and max. But no, on a lot of car amplifiers, you'll find that when the gain dial is denoted in volts, you'll see that minimum gain will be like 6 volts, and maximum gain will be like 0.2. That means if you feed the input RCA with 0.2 volt RMS sine wave, then the amplifier will be hitting clip point. Clip light never turns on. Even on oscilloscope, it shows no clipping with 4 volt pre-out from head unit. So your head unit might be 4 volt pre-out, but it won't be giving out 4 volts. The only time your head unit gives out the full 4 volts is when the head unit volume is at max. And for head units that have a separate sub-level, the sub-level will generally always be maxed out as well. Some head units is different. Alpine, you need the sub-level maxed out because it ranges from 0 to 15. But on head units that have that range from 0 and you can go plus 15 or minus 15, generally at 0 is where it is. So provided your sub-level is either maxed out or like in the middle, and your head unit's to max volume, then you should be getting a 4 volt output. So if you're not clipping, if you can't reach your amplifier's clip point, that means you've got horrendously low input signal going into the amplifier. Like, that's the only way. It's very, very simple. You give an amplifier signal, it outputs based on the multiplication that you ask it to output on the gain knob, right? So if you can't reach clip point, then it's just not getting enough signal. That is black and white. There's no other magical alternative to it. So the answer then, my friend, is to set your gains with your head unit volume higher than it currently is. Like, most Alpine head units do not clip, okay? You can go all the way up to volume 35 if you've got a stupidly like high auxiliary input level, then you might clip, like the last click or something like that. Typically, a lot of head units, generally, they won't clip, okay? I've tested this with hundreds of different head units. Most of them don't clip because that's kind of how it is. You have a volume control. It's a volume control. It's not a gain control. Head units have a volume control and they're all kind of calibrated inside, especially if you're playing CDs or if you're playing anything that you can't adjust the actual input signal level of, like a CD. You can't adjust the amount of signal from the CD into the actual head unit's stuff, or like a file. Then the head unit will be calibrated so that when it's playing music from a CD or file or something like that, where it has like a digital volume that is preset and calibrated, it won't clip when you turn it up, or even to maximum. So I would suggest that you would use your head unit to like pretty close to full volume, like over 3/4, okay? Use that as your head unit's volume for setting your gain point, and make sure your sub level is either maxed out if 0 is the minimum, or at 0 if it has plus and minus either side. You could even go up to like +6, it's fine, just to give the sub signal a little bit more. Then you should find that you have enough signal for your amplifier to reach clip point and therefore to set it correctly at clip point. What's your opinion on the kicker warhorse? Well, Richie, at the time that they made that, it was an engineering feat. It was a masterpiece. It was the way that they designed the warhorse was like one of the only ways to get a true 10 kilowatts at the time. That's a diesel one. You get a lot of diesel ones going past in the evenings. But yeah, that was like the only way to get full legitimate 10 kilowatts at the time. MOSFET technology wasn't there yet. Well, it uses MOSFETs, but it's a very way. You'll see my video on it. If you want to know how the kicker warhorse works, I did a whole video explaining how it works. And it is like, from an amplifier perspective, it's fucking terrible. It is like nasty, distorted mess, absolute flawed, terrible thing. It's not even an amplifier. It's just like a dual opposite wave inverter thing with a massive gap in the middle of the sine wave. It's terrible. But, and this is the thing that I say to people online all the time, man, I tell you what, I'm not blowing my own trumpet or anything here, but being on the forums, being on the Facebook Basshead group forums, right, being like an amplifier repair technician like myself that knows a bit more than the average Joe about how this stuff works, right, and seeing some of the advice or some of the stuff that people come out with, people say that bass amplifiers can sound different to one another. People say, oh, you'll never get the sound of a Korean from a Brazilian. And that drives me nuts, because the only reason people think that is because A, they don't know how to set their preamplifier circuit properly. With an amplifier that's running a subwoofer, subwoofers are so not fussy. They are not fussy. They are so slow and they are so terrible at reproducing fine details and distortions and stuff like that. They just smooth everything out. You will never, right, for a start, any amplifier that creates a clean sine wave, by clean I mean like on the scope it looks like a sine wave, okay, that's what I mean by clean. I don't mean like 0.1% THD versus 0.5% THD. You'll never hear the difference between that anyway, but anything that creates a clean looking sine wave on a scope, you will not hear the difference between that and any other amplifier that produces a clean sine wave on a scope, be that Digital Design's Z2C or Taram's HD10K, fucking anything, okay? They all sound exactly the same if you feed the subwoofer with the exact same RMS sine wave. It's just a sine wave. They don't make different shaped sine waves, they all make a sine wave, okay? The differences in sound you get between these amplifiers is the differences in the preamp circuits, which you can get around by not using the preamp circuit, by running it actively, even off a head unit. I'm not even saying use a DSP. And the problem is, the reason people say Brazilians sound different is because on their Korean amplifier, they'll turn the low pass filter up to about a third, which is about 65 to 80 hertz. They turn the subsonic filter up a little bit, which probably starts rolling off the frequencies around about 25, 30 hertz, or something like that. Starts rolling off about there. So those amplifiers, they sound smooth. They sound very smooth. There's not a lot of high kick bass, transients coming through, absolutely no vocals coming through, by no means, no shadow of a doubt, because the filters are pretty sharp roll off in those amplifiers. And yeah, they sound smooth and deep, and they produce a lot of power on low frequencies because that's how the preamp is set up. Now, when that guy who's been running a Korean for his whole life now goes and jumps on the Brazilian bandwagon, gets himself a Brazilian, he's looking sort of at the side of the amplifier, at the knobs, and can see that the low pass filter, instead of going up to 200 hertz, goes up to 10 kilohertz, but he's still turning up to about a quarter, maybe even just under a quarter. Okay, thinking, that's probably about right. And he's turning the subsonic filter up a touch. Okay, it needs to be up a little bit, doesn't it? Yeah. Now, all of a sudden, his Brazilian amplifier, all of a sudden he's asking that Brazilian amplifier to send to the subwoofer not up to 85 hertz. He's asking that amplifier to play unattenuated all the way up to like 250 hertz. And he's turned the subsonic up a little bit, which actually on those Brazilian amplifiers a lot of the time starts attenuating frequencies as high as 45-50 hertz. So all of a sudden he's gone from having a big, his kind of playable band of frequency range between 25 and 70, 85. All of a sudden he's shifted that up big time into the higher frequency range, where anything under sort of 40-45 hertz is going to be attenuated, and he's going to be still playing frequencies all the way up to like 200 hertz without even meaning to. And therefore he's like, oh, this Brazilian amplifier sounds whack, it doesn't sound smooth, it's too like punchy, like it clips on the beat drum, which it will do because those subwoofers have no impedance rise up at like freaking 150 hertz. When that kick drum is coming in, that sine wave on that kick drum is going boom, 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 like full high, really high level, and it's going to clip the amplifier because there's no impedance rise up that high. So yeah, you're going to get clipping on the beat, and they don't sound as smooth because you haven't set it up right. If you, on Brazilian amplifiers that are full range, if you leave all the filters at zero, that's the low pass filter at zero, which is usually about 80 hertz, subsonic filter at zero, which usually is fixed at like, I don't know, 20 hertz or maybe 25, something like that, and then you set a low pass filter on your head unit or DSP, whatever it is you're using actively, at like 65-70 hertz, so chop it off sharply. They sound amazing. The amplifier stages in these amplifiers don't sound any different. Now, I was going off on a slight tangent because I was talking about the Kicker Warhorse. Now, the reason I was talking about the Kicker Warhorse is because the Kicker Warhorse is a fucking terrible sounding amplifier, because you can physically hear, if you put your ear to the woofer, the crossover distortion point in the sine wave, where it crosses over from the bottom half of the sine wave to the top half of the sine wave. But people don't notice it. They listen to the Kicker Warhorse, it sounds great, and it does, it sounds fine. The subwoofer is so unfussy to distortions and differences in the sine wave shape that it fucking smooths it out. When you play it loud, the subwoofer just continues moving forward. There's a small gap in the sine wave, but the subwoofer just so heavy, it just fucking drives straight through it. It doesn't react to it quick enough, so you don't hear it. So when people say, oh, this bass amplifier sounds better than this one, or this is an SQ subwoofer amplifier, it's fucking bullshit. You can't hear the difference. You can barely hear the difference between different mid-range amplifiers, where there is actually some truth in the tonality of their sound, the amount of detail they can produce, the stereo separation, channel separation, and all things like that can impact how nice an amplifier sounds on directional, detailed, high frequency sounds. But when you're talking about under 100 hertz, It's a fucking sine wave. It sounds exactly the same. The only thing that makes it sound different is the amount of power you've got and your filter setup. So the Kicker Warhorse is a piece of shit amplifier, but for the time it was an engineering masterpiece, a way to get ridiculous amounts of power, 10,000 watts at the time, which was absolutely unheard of, and monstrous amplifier. And they got loud and they sounded fine because subwoofers don't care about the distortions that they introduce, and it's all good in the hood. Wait, let's check this out. So we're going to convert some people this evening. So No Name says, if you honestly think that you cannot audibly hear the difference between different amplifiers, you need to go back to the drawing board. You might be tone deaf. Yeah, but how on earth do you feed an audio pipe sine wave identically the same way as a focal sine wave? What? It's a sine wave. Audio pipe sine waves are not trademarked. They're not different shape to focal sine waves. It's just... I might have some piece of shit. I actually have some piece of shit amplifiers here. I've got some really piece of shit bass face. I've even got an Auna. You know that brand, Auna? The Chinese nonsense? I've got some piece of shit amplifiers, and I've also got what's it called? Not Hertz. What's that brand that make DSPs? Helix. I've got a Helix amplifier that is a tube stage amplifier here, which is like proper SQ. You know, it's like, oh yeah, banging tube preamp stage. So I've got a high-end SQ amplifier and some Chinese piece of absolute dirt bottom of the rock Chinese amplifiers. And if you really want, we can have a look at what they look like on the scope and see if their sine waves look any different. And we can even play it through a subwoofer. I can even get a little sub out, and we can see if we can hear any difference between the sine waves on the subwoofers. And because I've got my RTA mics hooked up, these microphones that you're listening to me on, they're actually real-time analysis microphones, so they are dead flat. Obviously YouTube compression is not good, but yes, no, my friend, honestly, there is no audible difference between these different amplifiers. The only difference between qualities of subwoofer amplifier is how much power they produce, and how long they last, and how efficient they are. That's literally all it is. You can take super cheap circuit design, really crappy amplifier, provided it's the power that you need, it's going to sound as good as like an amplifier that costs 10 times as much. It won't last as long, it won't be as efficient, but provided it's within the power band that you need, it sounds exactly the same. It's absolutely fine. You don't need a super high quality subwoofer amplifier in terms of like quality of sine wave reproduction. It's just a sine wave. You can't tell the difference. The subwoofer doesn't care, it doesn't know the difference either. This is actually a video that I am working on at the moment. I'm writing the script for, and I'm starting to take some kind of preliminary B-roll footage for. I've got a whole bunch of video ideas lined up about this kind of stuff, about this kind of controversial stuff that everyone kind of agrees on that must be the case, but that's not actually true. Things like clipping. There's another controversial thing for you. Clipping damages subs and speakers. Yes and no. We'll wait for the video to come out on that one. That's going to be really interesting and an eye-opener. But yeah, clipping and whether it damages subwoofers is one video topic. Different qualities of subwoofer amplifier and SQ subamps versus cheap subamps is going to be another video that I'm working on. That's going to be really fun. It's going to open some eyes a little bit. Anyway, we kind of come off the mark a little bit here. let's go back to this amplifier. Let's actually see what's going on. So let's turn the power supply on real quick, and let's have a quick look at what's going on here. So this is, if you just joined us, this is some random piece of crap amplifier that I just pulled off the back of the shelf that I was keeping as a spare parts amplifier. But I noticed that actually I hadn't used any parts from it yet, and I wanted to see what was wrong with it. I thought it could make a fun video, so The circuit design is actually quite nice. It's a very similar circuit design to some Sundown amplifiers, Sundown SAE amplifiers. They're either 2K or the SAX amplifiers. Yeah, pretty nice modern circuit design. Actually, decent amplifier. This Power Acoustic don't make nice amplifiers, but this is actually a decent board layout. It's decent build quality. It's quite nice. So let's start cranking up the voltage. Well, that's it down to 0 for some reason. We're going to start off with a 9.5, around about there, about 9.5 volts. We're going to get let about 4 amps into the board right now. We're going to take our oscilloscope probe, set the scope up to the correct settings for diagnosing this. Going to go down to about 5 milliseconds divide, reject low frequencies, and we're going to go down to 10 volts divide. And I'm going to start by probing the power supply MOSFET drain. We're going to just make sure that the amplifier wants to try and power up. And that the power supply PWM circuit is working as intended. So let's just see what we have here. Oh yeah, little pulse of the remote. You saw that there. That was the drain wave. Yeah, that's working. So the power supply is working. Okay, so we've pulsed a couple of microseconds into the power supply now. So that should have built us a little bit of rail voltage. So if I go over to the output FETs now, which are over here, I should be able to see some DC voltage. Yeah, there we go. So this is the low side MOSFET. We have negative rail on pin number 3, 0 on 2, and should have negative rail on 1. Yeah, we do. And how about the high side? We should have positive rail on 2. Yeah, 0 on 1 and 3. Well, that's all looking good so far. So I'm now pretty happy to go ahead and power this amplifier up fully. So let's put our probe on the power supply drain, and let's turn that on until we build full rail, 1.6 amps. Okay, so the amplifier is now fully powered up. We have a green light, in fact, on the amplifier. There's a green light over this side. Yeah, there we go. So the question is now, do we have output switching? Oh, no, we do not. Okay, here we go. I thought this would be an interesting one. This is going to be fun. Okay. So when we turn the amplifier on, I'm probing the low side drain, okay? So the low side drain is where we should see the big switching wave from the output section. So if we actually turn the amplifier on, you can see there that we don't get any switching, we just get a big swing, like an instantaneous swing to negative rail. Like, yeah, straight up to negative rail. So, interestingly enough, the amplifier is, like, the drive circuit isn't failed to the point where it's going to kill the FETs. What it's doing is currently at the moment the output drive circuit is currently telling the low side MOSFETs to turn on, but it's not telling the high side MOSFETs to turn on. If it was telling the high side MOSFETs and the low side MOSFETs to turn on at the same time, then those voltages would touch each other and they would cancel each other out, and it would just draw a shitload of current. Whereas what's actually happening is it's telling the low side to turn on, but not the high side. So we just get this big swing to negative rail on the speaker terminals. As you can see over here, we don't actually the relays don't even engage. So yeah, I think maybe is that because we run off voltage. The protection circuit isn't active. It's not going into protect, which is interesting. So it's not detecting. It's not like going into protection mode. But the relays aren't engaging, which is good, because if the relays did engage, and any speaker you had connected would get, like, what's that, negative 70 volts DC, which would definitely not be good for the driver. So the relays aren't engaging, which is good, but it's not in protect, which is very interesting and confusing. But we have straight up DC on the low side drain. So that's the problem. The problem is either in the drive circuit over here, or it's in the auxiliary voltage generation circuit over here. So when you've got an amplifier like this that doesn't have any dead FETs, doesn't have any dead capacitors, nothing seems blown or broken on the board, but you get a big swing to negative rail like this, then that can sometimes be caused by the output drive circuit here not being fed with the correct supply voltages. So this drive circuit here, if we go to this camera and do your cheeky zoom in, you can see here, this circuit here, this will require specific, voltages in order to generate the PWM. It's going to need plus minus 15 volts or plus minus 5 volts for some of these smaller chips on here, and then this big chip here, which is an IRR2110S, this is the actual MOSFET driver, this is going to need 12 volts referenced to negative rail. Now, the time when you would see DC on the speaker terminals like this, or on the low side drain, that's typically when you've got a missing auxiliary voltage, like usually either one of the plus or minus 15 volts. When that happens, either the preamplifier circuit, which is over here, will only have half of the op amp powered up, and therefore it will be sending DC out through the signal input, which will be asking the drive circuit to just send DC to the speaker terminals. So the issue will be in the voltage regulation circuit there. Or if you've only got plus 5 or minus 5, then part of the circuit that generates that does the conversion from the sine wave to PWM, which is these two op amps here, if you've only got plus 5 or minus 5, then this won't work properly, and you will just end up with either a logic true or logic false, you know, a 1 or a 0 on the outputs of that PWM generation circuit, which the driver will then just pass straight onto the MOSFETs. So I think this is going to be a lack of auxiliary voltage. So let's take a look, shall we? Let's see what we're missing. So a good thing to do is we're going to power it up, and we have these op amps on the output drive circuit here. And like I said before, we need these op amps. They require plus and minus VCC voltages. So there should be like plus 5 and minus 5, or plus 15 and minus 15 on their VCC pins. From memory, I think it's 4 and 8. So on pins 4 and 8, we should see some opposite, equal, mirrored voltages. So it's powered up again, and let's see what we have. So on pin number 4, we have nothing. Pin 4 has just a tiny little hint of voltage, barely anything. On pin 8, we have again 2.5 volts. Again, literally nothing. So that's not right. We are missing some auxiliary VCC voltages here. Although, what's this over here? That op amp seems to have. Actually, this might be a comparator for something. Hang on a minute. Is this a single op amp? What do we have? We have an LM393. We have two LM393s. One of them has. Oh wow! Something's getting very hot. I can smell it. Let's get the thermal imager out. So whichever component is bad is cooking up, which is good, because that is kind of like a nice visual representation of what's going wrong. So let's take our thermal imaging camera. Like, I instantly got the smell of hot electronics there. So let's just see. Oh wow, very hot. What do we have over here? We have, okay, that's what I thought. This is the auxiliary voltage generation circuit over here. Now these two over here, which is the TIP41C and the LM337, these were both reaching pretty toasty temperatures. Now that could be normal, because these are voltage regulators, right? So these are designed to drop voltage from a high voltage to a low voltage, so they will run hot. That's why they need to be attached to the heatsink pretty much at all times. So they will run hot, that is normal. But if they're running ridiculously hot very quickly, then it either means that they themselves have failed, or some component that uses them is shorted, therefore drawing excessive current from them. So what I'm going to do is I'm going to take my thermal imaging camera, I'm going to look at the board and see if there's anything else on the board that heats up. So obviously it's clear that these are heating up over here quite considerably and quite quickly. 60 degrees, 65, 69, 70, 70 degrees, 76, oh fucking hell, 80 degrees, yeah, they're cooking up, roasting hot in like no time. Elsewhere on the board though, have we got anything else getting hot? Oh yeah, there's something, oh wow, something getting really spicy over on the drive circuit here. It dissipates its heat very quickly, but it reaches a whopping, what are we looking at? Not actually that hot, but kind of toasty, 50 degrees. Something over here is reaching about 50 degrees on the drive circuit, so that's worth looking at. That could be something that's shorted. Another thing I just want to check for is make sure we've got no shorted op amps in the preamp circuit, because that can also be an issue. Okay, cool, no worries at all. So that is a nice little hint as to where we need to look. The next thing I want you to do is I want to power it up again, just very briefly. I'm not going to hold it on for too long because I don't want these parts to overheat if they're actually fine. I have got an impression that the voltage regulators over here actually are fine. I think that the issue is going to be something drawing current from them and therefore causing them to heat up. So I'm just going to power it up again a little bit, and I want to see what voltage we have on the preamp op amps, because these will usually have the straight DC plus minus 15 volts. These ones over here on the drive circuit for the output section will usually have like the smaller VCC voltages, plus minus 5 volts. But these ones over here in the preamp circuit will usually have plus minus 15. So I just want to see whether we have that. Let's power this up again briefly. So look. Okay, no. Again, we only have plus 2 and minus 1. So both plus and minus 15 volts or plus minus 5 volts are not working at all. On this one we have the negative rail, which is fine. That's probably going to be what applies the PWM to the negative rail. Okay, cool. So the next thing that I'm going to do is read some live chat. Now I'm going to talk you through what to look at next to pin down on whatever component is causing the VCC voltages to just disappear. Yo, Matt Streetman, dude, thank you very much for the 5, buddy. That's awesome. Can I send you my Wolfram? I put it on half ohm, didn't blow it, but it won't come out protect. So yeah, sounds like you blew the output section. My friend, yes, but no. I'm based in the UK. For you to ship an amplifier to me is going to cost more than the amplifier's worth, probably just in a one-way direction. You've got to ship it to me. You've got to pay shipping costs, you've got to pay the import, duty, tax and fees into the UK, then you've got to pay for the repair, then you've got to pay for the shipping back to the US, then you've got to pay for the import, duty, tax and fees back into the US. By the time you've done all that, you probably could have bought yourself something really big. So I would happily fix your amp for you, but it's really not worth the money in shipping. So Martin, it brings up an interesting point here. What about damping factor? Does it matter? Damping factor used to be very important. So damping factor, for those of you who don't know, is the amplifier's ability to bring the cone to a stop once the signal has stopped, right? So if you think about an amplifier, imagine an amplifier producing a sine wave, okay, brr, in, out, and then suddenly, boom, it stops. Suddenly, boom, it stops. Now, a speaker is a mechanical entity. So when you've got a speaker with a moving mass, a mass that's moving, it's got inertia. When you ask it to stop, it doesn't just freeze in time instantly. It will have like a ring or pendulum moment to it. If you just play a speaker and you just remove the wires instantly, so you got the speaker connected, playing a tone, and you just instantly remove the wire. You will find that the cone of the woofer doesn't just instantly stop. It's moving like this. You remove the wire and it goes. It like comes to a stop, but it has some ringing before it comes to a stop. Now, when you've got that speaker connected to an amplifier, when the signal stops, that speaker that is moving, it's generating its own electricity as back EMF that it sends to the amplifier. Now, because it's sending that bit back EMF to the amplifier, the resistance that speaker sees on its terminals while it's creating that energy back into the amplifier, the lower the resistance that has across it when it's generating the electricity back into the amplifier, the quicker it will come to a stop. The quicker the harder it will stop, because it's very hard to drive a low impedance load like that. It's the same as when think about your alternator. Your alternator is like that subwoofer that's moving. It's a coil of wire moving in a magnetic field. It's generating electricity, the same as an alternator. So when you've got your alternator running and you're sitting idling at the lights, you're sitting at the lights in neutral, and suddenly you crank the bass up, you might notice that your revs drop down, they dip, because your alternator all of a sudden becomes much harder to turn, much harder to spin, because it suddenly has a low resistance on the alternator's outputs, which causes the engine to, it causes the alternator to be much harder to turn. The same thing happens with the speaker when it's being brought to a stop. The damping factor of the amplifier will dictate how quickly that speaker is brought to a halt. It's the kind of amount of control, the amount of damping, the speed at which the amplifier can stop that cone from moving. Now, this was a relatively important specification way back in the day when loudspeaker drivers were extremely soft suspension and very high sensitivity, like super soft. You know those really old woofers where you take them out the box and you can literally, like, the cone is like spongy soft. It's like super low FS. Yeah, so it was important for those kind of drivers that were low power, extremely soft spider setup and stuff like that, because they needed the help of the amplifier to come to a stop. Because they didn't have much mechanical compliance of their own, they would just carry on ringing for quite a long time if the damping factor was super low. So high damping factor generally turned into more accurate, punchy, tighter bass and a more kind of impact, kind of transient sound. However, these days, the drivers that you'll use not only in your subwoofer application for your car audio setup, but also in any instance, whether you're looking at home cinema, hi-fi, pro audio, drivers have become so much more powerful that they are able to have much stiffer suspension setups, whereby the mechanical compliance of the driver itself outdoes by leaps and bounds any damping factor the amplifier can apply to the speaker. So if you had like an average car subwoofer these days hooked up to an amplifier with a terribly low damping factor, and then hooked it up to one with an incredibly high damping factor, you played a sine wave and you instantly stopped it, and you measured the amount of ringing on the cone with an RTA and a scope on a graph, you wouldn't see a difference, because the mechanical compliance for that woofer to stop and damp would be so much greater percentage, like the amount that affects the damping is so much more than the amplifier can ever produce on it, so you wouldn't really see a difference. So damping factor used to be a really important specification, but these days you can pretty much largely ignore it. It's not going to make any difference to how your sub sounds. So you went and looked up Photonic induction. Holy crap, Tron, you had not seen his videos before. Jesus. Yeah, dude, go back through. Take yourself, if you're bored one evening, go on a craze on his YouTube channel. Just watch all of his old videos. Absolutely fantastic stuff. Really amazing old school content. Hey you, can you fix it? I bloody well think so. Let's see what we can do, eh? EMF said your mother is a terrible cook. What? What? Oh wow, hey dude, Matthew Macy. Man, my man! Thanks for the 20, bud. Massive appreciate that. That's awesome. What's up? Just dropping in to show my support at work, and we'll have to watch the full stream later. Get to see you streaming again. Oh man, appreciate the 20. That's massively kind of you. Thank you very much, man. Appreciate that. I've managed to repair a customer returned blown Alpine 15 courtesy of Sam Streams and Knowledge. Dude, Rob C, nice work, man. That's awesome. Good job. Yo, what are we talking about, Shane? Hang on, let's have a look. Oh no, Shane. What's that? Give me a name, Sam. I'll give you a name. Wait, it's icon. Oh yes, Shane can fix it for you. Sorry, if you're based in the US, Shane will probably fix it for you. Sakura says also, I use a phone to play my music via Bluetooth and FLAC files from my phone. Would I still benefit from an external DAC? If so, what DAC would you recommend for Bluetooth streaming? So Bluetooth is a bit of a sticky one, because if you're using FLACs and high resolution files and stuff like that, then the only Bluetooth that's going to work for you is, I think it's called LDAC. No, fuck, I looked this up in so much depth when I was looking at my own install in the Proton. And I was thinking, do I want to Bluetooth it? Is there uncompressed Bluetooth available now? I can't remember what the name of it was, but there is a type of Bluetooth that has to be supported by both ends for lossless transmission of data, like high speed, so that it's worth you listening to FLACs. My advice for you, which is what I ended up doing in the Proton, is get yourself a topping D10, which is a digital to analog converter. It's a DAC, but I'm not using it for its DAC purposes. All I'm doing is I'm using the topping D10 as an interface between my USB-C mobile phone connector. So I plug my USB-C into my Android phone, I play my lossless files or my Tidal lossless streaming service through the USB-C as just a raw data stream. So it doesn't get compressed or changed or affected at all. It goes straight in from the source, straight out through USB-C as raw data. The topping D10 then converts it into optical. So it doesn't recompress it or anything like that, it just converts the data stream down the optical line. So I have the optical output from the topping D10 straight into the DSP that has optical input. So when you're doing a system like this and you're thinking about highest quality sound possible, yes, you've got all these super high resolution files. The lowest amount of conversion that you can have, the better. So for example, if you've got a DSP will want to take your analog input. If you're feeding your DSP RCAs, it will take your analog input from your RCAs, it will convert it to digital so that it can do all its processing, and then convert it back to analog again for your amplifier's output. Some noisy diesel ones this evening, man, Jesus. That's a freaking long one as well. Fucking Jesus Christ. When she's like, is it long? You be like, it be long. So naturally, you want the minimum amount of toing and froing between analog and digital as possible. So by having your phone connected via USB-C to the topping D10, so it's raw data, digital, from the phone into the topping D10, converts it to optical, it's still the raw data into the DSP. The DSP then just takes that raw data, injects it straight into its processing brain to process it however you want, and then, only then, at the last stage does it convert it to analog for the RCA outputs to your amplifiers. That's what I'd recommend. And it works great. aptX HD Bluetooth, that is still not the be all and end all of that. That will not actually, that still compresses it. aptX HD still compresses it. I think it's LDAC. I think it might be the one. I did a bunch of research into it, but I can't remember what it was. I think aptX still compresses it. I think there's another one that's above that. Right. Anyway, too much side chat. Let's crack on with this. So we found out that there is some issue on the circuit preventing plus minus VCC auxiliary voltages being generated, and the voltage regulators over here are heating up to very high temperatures. So I'm just going to do one last continuity check between these, just to see if we have any low resistances between them. So we've got 409, 410, that's not too bad. High value, and that. So between legs 1 and 3 of this TIP, this is the 41, got 411 that way. If I flip the probes, we still have 411, so that's probably going to be more like a DC resistance. If I put the multimeter onto DC resistance mode, actually, no, it's not a resistance. Oh, you know, it might be. I'll put it onto one thing. Yeah. So okay, we have about 320 ohms between 1 and 3 of the TIP 41. which is not particularly high, but it's not particularly low either. Now let's see what we have on this one, which is the LM337. It's been a hot minute since I worked on this circuit layout. We have 316 ohms between 1 and 2, which is probably going to be output and ground again. So we have the same kind of resistance there on the 41 and on the 337. The one that wasn't getting hot, which is this last one, which is the TIP42, this one wasn't getting hot. So I imagine we might find that we don't have that, yes, we don't have that resistance there. See that? So we have just like super high resistances on the 42. Okay, cool. So now what we're going to do is we're going to see which components are using the voltages from which of these parts. So if we take a look at the preamp circuit over here, the preamp should be using plus minus 15 volts. So if we take a look at one of these op amps over here, we're going to look at which one is pin number 1, which I think is going to be, these are like all kind of old and almost scratched off, but we have pin 1 over here. So pin 4 and pin 8 are going to be the VCC inputs. So we're going to see what do we have having continuity to this op amp. We're going to need, let's have a look, does it go over here? Okay, here we go. So the output of this 337 is obviously pin 2, which is the back of this one. So that's going to be one of the VCC voltages, and the other one is going to be this one. Well, that's what we would expect, isn't it? We would expect it to be these two here, the ones that we're getting stanky hot. So we've got a TIP41 and we've got a 337. Now that's unusual. So the op amps will obviously be using the op amps will obviously be using the same voltage, just mirrored, so plus minus 15 volts. Now usually I would expect to see the TIP41 and 42s to be like the plus minus 15, and the 337 to probably be doing something else like the 12 volts reference negative rail, but actually that's not what we have going on here. Now these parts look like they have been removed and resoldered in the past, so I am willing to bet that maybe they've been put in the wrong places. Maybe they've been put in the wrong places. So gents and lady, you know what I'm going to do? Actually there's two 41s. Okay, maybe that is correct then. Sorry, my apologies, I couldn't read it properly. There's two 41s and there's this 337. So what I'm going to do first is I'm actually going to remove both of these parts, and I'm just going to put them in the transistor tester because I want to confirm first of all that they're okay. Yeah, because if they're not okay, then that's pretty obvious what the issue is. So start from the top, start from the most obvious fault and work your way down. Remove the parts that are generating the voltage that you're missing, that seem to have a low resistance across them. Another one, fucking hell. That was a small one. See, that was little Jimmy Two Chode over there, like millimeter Chode. That was him. So yeah, we're going to remove the part that's obvious. Once we've removed those transistors, we will look to see whether the resistance on the board is still present. If that low resistance on the board is still present, then we know that there is a short on the board somewhere which is causing these to heat up and not to have the correct voltage. So let's just lift them off the board and let's see what we have. That's the TIP41 and the 337. So these have been worked on quite a bit in the past by the looks of these traces here. Okay. Hopefully, gents and lady, I'm getting better with the hat cam. In the past, I have used the hat cam, and a lot of the times you end up just getting a nicer view of the old crotch area. So I've angled it slightly higher on my head this evening. Hopefully it stays angled at the board when I'm doing soldering and whatnot. Okay, so let's bang these in the tester, see what we have. TRP41. BJT NPN HFE 51.9, pretty about right. And this other one. Hey! Oh, hang on. I think an LM337 actually isn't a transistor. I've got a feeling that that actually might be an integrated circuit, so that would make sense why this can't read it. Let me just confirm. I think the 337. I think the LM337 is a programmable voltage regulator, which would be a bit weird. Why would they use a regular transistor for like the plus 15 and then a programmable voltage regulator for the negative side? That doesn't make fucking sense. I'm pretty sure that these have all been put back in the wrong places, gents. By whoever looked at this last. By the way, the trains, they will sound louder on the video than they do in real life. Like that one that just went past there, it's just like a kind of nice background kind of whooshing sound. But I think on the video, from when I've played them back, it sounds like the fucking apocalypse out there. It's not that bad in reality. And also, this is at the back of the house. This room is in the rear of the house, and the trains are out the back. And the master bedroom is at the front of the house, so you've got a whole house in between. And honestly, I don't hear them. You don't hear them at all. They're not that loud. It just sounds loud here because of these microphones, the RTA mics. They're really sensitive. So, yeah. So yeah, I'm not even going to Google that. I'm pretty sure that the LM337 is a programmable voltage reg. Yeah, Daniel Koch confirms. But you know what? That is confusing though. I think that these might all be in the wrong places. Why would the plus 15 be running off of a regular kind of Zener diode setup with a transistor, and the negative use a programmable IC regulator? I think that these might be in the wrong places. I've got a feeling that the programmable voltage regulator should be in the plus 12 volts reference negative rail location. Alright, right, let's check and see what's going on with this. So if we take a look at the output drive IC, okay, look at this bad boy. This is the IR2110S. This is the output driver. Now this is going to be needing about 12 volts reference to negative rail on its VCC pin. So if I go to the big fat internets right now and I look up the IR2110S chip and give you the internet screen, we can see, I think it's pin 3, is it? From memory? Can't bloody well remember. I think it might be pin 3. Yeah, I was right. Pin 3. I remembered well. So pin 3 on this bad boy should be connected to one of these voltage regulator outputs. So let's probe pin 3 on here. And let's go over to the voltage regulator output over here. Let's have a look and see where it's connected. Yes, it is connected to pin number 3 of this one over here. Now currently we have a TIP41C in there, which I am wondering if that's actually not correct. I am wondering whether the programmable voltage regulator should be in that position instead, the LM337. So I'm going to just quickly Google the LM337, and if pin 3 is the output, which it probably is, and I imagine that they're in the wrong bloody places. LM337. Ah, now this is adjustable negative regulator. Oh, that's weird. Because the plus 12 reference negative rail isn't a negative regulated voltage, it's a positive. Where's our pin out? There we go. So yeah, pin 3 is the voltage output. If we look at, now here we go, this is going to be the thing that tells us. If we look at the pads for the voltage regulation circuit over here, which are all fucked up because whoever worked on this last and put them in probably the wrong places. If we take pin 3, oh, hang on a minute. Aha! I think I figured the issue here, guys. I'll tell you why in a minute, but anyway, let's just take pin 3 of this for a minute. No, see, pin 3 isn't connected to any of these. It's pin 2. I think these are all in the fucking wrong places, you know. This is madness. So I'm checking between, right, the VCC pin for one of these op amps. The VCC for this op amp is connected to leg number 2 over here. So whatever's supposed to go here, the output is leg 2. And on this one, on the other VCC input for the op amp, the output is pin 3. See that? Now, the thing that's really got me thinking whether this is just someone's fitted this with some bullshit parts is that you see both of these here that are generating the voltages for the preamp, you know, the plus minus 15. Both of these are labelled IC. See what you've got IC31 and IC32. And that would suggest that these are supposed to be integrated circuits. These are supposed to be actual ICs, like the programmable voltage regulator. This one here, okay, which is going to be 12 volt ref negative rail, which is connected to pin 3 of the 2110. This one here is labelled up as Q81, which suggests that that should be a transistor, which it is. It's a TIP 41. So that's probably correct, but these probably need to both be programmable voltage regulators, not TIP 41, which is what was in there. So what we need to figure out is I need to remind myself which one of those pins on the preamplifier op amp is plus voltage and which one is negative voltage, because I can't remember because I don't look at this enough. So what we've got pin 4, which is connected to this one over here, the middle pin, and pin 8, which is connected to pin 3. So let's just quickly look up a TL072C, which is probably what it's going to be. TL072C, I think that's what these are roughly. What is it? Yeah, it is a 072C. So if we look at the 072C, and this is good educational stuff for you guys anyway, but the pin out for the 072C, 072, here we go. So, okay, pin number 4 is the negative voltage input. So that's going to be negative 15 volts. And pin 8 is the positive VCC. That's going to be positive 15 volts. Alright? So, negative VCC, negative 15 volts on pin 4. So pin 4, which is this one, is meant to be negative 15 volts. Let's go actually do this one because it's close to the camera. Negative 15 volts. So that is supposed to be this one. So negative 15 volts. We're supposed to have negative 15 on pin 2 of this IC. So therefore we need a voltage regulator that has the output on pin 2. And then on this one over here, you know what? I think they're supposed to... Fucking who even worked on this before? The parts in this board are supposed to be an LM 7815 and 7915, aren't they? And this came to me with a TIP41C and an LM3. What the fuck? Like, I couldn't even believe it, because when I looked at this earlier, I was confused, right? Because when you use a transistor as part of a voltage regulator circuit, generally the way that it works, the way that you set the voltage on it, is with a xenodiode or xenodiode, whatever it is, with a diode, right? You set the latching voltage of a xenodiode, use that to set the voltage which is going to be passed across the transistor. You can also, with a programmable voltage regulator like the 337, you can you'll need some kind of other components on the board to calibrate it, to tell it what voltage you want it to regulate, and none of that here is present. Literally on the board here we just have these big fat resistors, which are the resistors which are buffering probably the input, I think. Yeah, they're gonna buffer the input probably. So that's nothing to do with setting the voltage. And then there's a couple of tiny resistors here which are like smoothing resistors. They're nothing to do with setting the voltage. So when I first looked at that part of the circuit, I was like, this looks a bit fishy to me. So no wonder it fucking didn't work. That's almost as bad as someone putting MOSFETs in the rectifier stage. That's almost as bad as someone putting 064 ends in the fucking rectifier location. No wonder that bullshit didn't work. Right, that's good, gents, because I have some voltage regulators that we can shove in there, and I think we're going to get this thing working. So a couple of people here are actually in the live chat are saying that they should be the programmable ones. Honestly, from my experience, I don't think so. You might be right, but I honestly don't think that is the case here, right? Here's how we tell. Okay, a programmable voltage regulator. Check this out. Okay, this is how we tell which one it is and who's correct. A programmable voltage regulator like the LM337. Let's take a look at what pins we have. Okay, let's take a look at the pin out. Here we go. Okay, so we have 3 pins. Very simple. Adjust pin, which is going to be what you connect to the adjustment circuit for setting the regulated voltage. Pin 2, voltage in. Pin 3, voltage out. Okay, very simple. So if that's the case, then none of those pads should be connected to ground. Okay, and if any of these pads are connected to ground, what has a ground connection? LM 7915 and 7815, they have a ground pin. So if any of those are connected to ground, then we know that they're supposed to be the regular linear voltage regulators. And let's see what ground are they going to be referenced to. Oh, hang on a minute. We might have something. You might be right. Hang on a minute. Ground. I'm just trying to find output ground. Give me a sec. Okay, there's output ground. Oh, you know what? They might be onto something in the live chat. They might not actually be LM78s, because if they were, then they should be connected to ground somewhere, which they don't seem to be. None of their legs have a ground connection, which is interesting. So maybe they are programmable. Maybe these ones are the programmed ones. Alright, next thing, let's power the board up with these parts missing. And let's see what voltages we see on the pads for these parts. Because that will obviously tell us a bit more about this, whether it should be programmable or not. Okay, let's get some voltage in here. Power this baby up. Yeah, wrong pedal, sorry. Okay, let's have a look. So we have on this one, okay, 0 volts, 0 volts, and plus 30. Okay, now hang on. Let's flip the board back over to remind myself which one's which and what's supposed to be where. So on pin number 3 of this second one, we have actually what looks like positive rail. No, not even positive rail, just some high voltage. Oh yeah, no. Yep, it looks like... Okay, half rail. So we've got 30 volts on pin 3 of this location. So that's got to be our input. And our output is going to be the pin number 2. So whichever is connected to ISO IC31 has its input on leg 3, its output on leg 2, and its adjustment on leg 1. Now this IC32, this first one right here, we have 0 volts on pin 3. Pin 2, we probably have something, but the trace is missing, so let's go on to the underside of the board and have a look. Okay, yes, on pin 2 we have negative 30 volts. See that on this scope there? And on pin 1 we have nothing. Now I think with these adjustable voltage regulators, I don't think you see a voltage. I think it's just like a resistance type of thing to set the correct voltage for calibrating these. So, hey, who got it right in the live chat? Well done. Well done. Hello, let's have a look. See what people were saying. Oh, dude, DL carburetor. Dude, thanks for the 10. Bye, Sam. Gotta go, my friend. I'll listen to the rest of the stream later on replay. Thanks for the 10, man. Massively appreciate that. That's awesome. Yes, the LM337 is an adjustable voltage regulator by means of resistor values based on input voltage, which will make sense because we have some small resistors, some surface mount resistors there by pin 1, which I honestly didn't think were for that. If I had to put my money on it when I was looking at it a minute ago, I thought this was going to be an LM or a KA situation, but it wasn't in that case. Congratulations, you guys. Well done. Good foresight on that. Whoever said that it was going to be the programmable ones, nice one. But yeah, we figured that out by seeing there was no ground connection to any of those pads, and the fact that we've got 0 volts on those adjustment pins. That means it is a resistance style calibrated adjustment. So got some more information in the live chat right here. Someone says you need 2 LM337s and 1 TRP41. A couple other guys say you need a LM317 to pin 8 and a 337 to pin 4, which would make sense because if we look at the data sheet for this here is classified as a adjustable negative regulator. So I imagine that my man in the live chat right here, LM317, is going to be the positive voltage version. Yeah, there we go. There's the positive voltage version. And on this one, we should find that we have the input on the other pin. I've gone past it. So on this one, we have input pin 3, output pin 2. Whereas on this one, this one, we have, yes, that's correct, input pin 2, output pin 3. Yeah, so they are the opposite way around. So that is most likely what we need then. Nice one, very well done. give a big round of applause to the guys in the live chat that said you need a 317 and a 337. You've done your homework. Well done. Good stuff. Nice. Yes, LM7815 and 7915 would be labelled as IC. That is because that's what they are. They're an integrated circuit. They're not a transistor. They're not a MOSFET. They're not a resistor. They're not a capacitor. They're a circuit. It's a voltage regulator. So yeah, they are rated as IC on the board. Q is for transistors. Now the sad thing is I don't actually know if I have any 317s. So we've got a 337, and there was a TIP 41. But actually, now the one thing that we didn't check is we didn't check whether that lowish resistance on the board is missing. But that lowish resistance might have been the resistance to set the. It might have been the resistance to set the regulator. Yeah, I've got 400 ohms. That might actually be that's on the adjust pin. So that's fine. That's not the issue. That's fine. That will probably just be to set the voltage. Now, where should I go looking for one of these then? In my parts drawer. Do I have a spare one of these? I want to get this amp up and running this evening. It'd be really nice to see. LM337. Because I don't think this is the only issue. I don't think that this is the only problem here. I think there's going to be other stuff wrong with the board, but I want to find out. So LM337. I need an LM317. Let me try and think where I might have put one of those. Just looking through my parts tray here, see if I. Oh, hang on, what have we got? Hey, hey, what's this? It's a KA 317. That might do the trick. I think that's going to be the same. Yep. Yep, input. So input on pin 3. Yeah, that'll do. Wicked! Freaking awesome. Good job. Alright, let's get that bad boy loaded up in there. Let's just make sure it's not shorted first. You have a no with me. Yep, looks good. No shorts. Alright, let's load this bad boy up then. So that one, remind myself, that one. This one is the positive, which is going to have the output on pin number 2. So the output on pin number 2 is going to be pin number 2. Was that this one? Shit, the trace is missing. Wait a minute. Let me just remind myself. Oh fuck. Traces are all fucking broken on this piece of shit. Positive is pin 8, so that's this one, and that should be pin 2. Okay, right, so right, output is pin 3 on that one. Right, so that's the negative one. No, wait, what? Oh no, shit, hang on a minute. What the fuck? No. 137. Oh no, I got that backwards. I got the wrong fucking one, haven't I? LM317 and LM. Wait, what the? Hang on a minute. LM13. Fucking, there's too many 3s and 7s. The live chat's probably kicking off right now. They're like, oh no, it's the wrong fucking one. Sorry. Too many same numbers, too much wine. Right, the parts I need are LM317 and LM337. So I need a 317. What I have in my hand is a 317. Yes, that's correct. But the 317 over here, the LM version, shows a pin out, which is adjust output input, whereas this one shows adjust output. Yes, that's correct. Fucking okay, fine. So VCC plus is pin 8 of the op amp, so that should be connected to the output, which is not pin 2. Am I just getting myself confused here, or is this not making any fucking sense? Pin 8 of the IC, which is a 072C, right? 072C, which is that, sorry, my head got in the way there. 072C, right? That's pin 4, that's pin 8. Pin 8 should be connected to plus VCC, correct? Yes. So plus VCC, based on this, should be positive voltage regulator, should be pin 2 output. Yeah? Except pin 8 is actually connected. Oh, for fuck's sake, it is. No, it's not. It's connected to pin 3. It's not, that is connected to pin 3. So pin 8 is connected to pin 3, which is input. Well, that doesn't make any fucking sense, does it? Whereas this one, pin 4, which is supposed to be negative VCC input, is connected to pin 2. Pin 2 is the output of the positive. So it's backwards. My bad. My bad. I just realised what I was doing wrong, guys. I was reading the op amp upside down. I was reading it backwards. The marking on this op amp is incredibly hard to see. I'm trying and zoom in a bit further here. This is obviously a really, really old op amp, and you have to get the lighting just right, and the font is like very digitized. Who nailed it? Who nailed it on the head? Someone nailed it on the head. Marcin in the live chat nailed it on the head. He said you're holding your probe on pin 4 of the op amp. You're right, my friend, I was. That's my bad. That's my bad. So that's actually correct then. That is actually correct. This is fine. I was just looking at the op amp and I was assuming it was upside down in my head, whereas it actually wasn't. Anyway, so now that we've figured out what I was doing wrong, let's put these voltage regulators in their correct places then, shall we? So yes, looking at this right around now, this is pin 1 over here. This is pin 4. So pin 4 is connected to pin 3 of this, and pin 4, based on the data sheet, is supposed to be pin 3 on the data sheet is the output of the positive. Nope. Pin 3 is the output of the negative, which is the 337. Okay, great. So the 337 goes there. So 337 goes in there. And the 317 goes in there. Are we happy with that? How are we feeling? Is this going to turn into another live chat fixes the amp? Mike Honda, man, thank you very much for the $20, my friend. That's massively kind of you. What's up, Sam? Whole family here. Just got in. Just got here. Where are we at? Oh, you missed a whole bunch, my friend. You missed a whole bunch. This live chat, this live stream's been pretty funny actually. We chatted about some interesting stuff. Right now, live chat is fixing this amp for me. I'm not really with it. It's absolutely roasting here. It's like so heavy. Whether I'm making many excuses for reading this op amp upside down and getting confused about why the fuck pin 4 is connected to negative when it should be positive, or vice versa. But it's been a good stream so far. I was looking at this op amp on the board and I was trying to read the markings, which are incredibly hard to see, and it looked like the 072C was upside down to how it actually is. So I was assuming that pin 1 was over here, whereas pin 1 is actually here. So I was getting myself confused. I was like, why is pin 4 connected to the bloody opposite type of fucking thing that it's supposed to be? So, okay, let's put the correct voltage regulators in the board and see what we have. Let's get these soldered up. Now, this board has been mutilated by whoever worked on it before. We had a TIP41 in the voltage regulator location, which obviously was wrong. And all the pads are missing. All the pads are fucked and shit. It's all just a mess. So we're going to have to solder it to top and bottom of PCB to make sure that we have a good connection to all the traces here. Okay, this trace is kind of missing its pad, so I'm just going to scratch away at the insulation a little bit there. And I'm actually going to make a really solid connection on this simply by scratching away a bunch of this insulation on this trace that's missing its via and missing its pad. Scratch away a whole load of that insulation so that the copper trace is exposed. And I'm going to tin the trace that I just exposed, and then I'm going to fold down that leg onto the trace. See that? So that is now mega solid. There we go. I probably need to go ahead and solder a couple of these to the top of the board as well, because their vias are all missing, so I want to make sure that they have connection to the top PCB where they go. So we've got the 337 in the first location and the 317 in the second location. I think that's right. Holy shit, these traces are bad. These traces are fucking terrible. The whole pad's missing from the top and everything. I don't think there's anything else supposed to be on the top PCB for this one. Okay, let's see how that goes, shall we? So that's the 2 voltage regulators in there. So, technical specialist, in the UK, no one has air conditioning because we only get like 2 weeks of the year when you really would need it. So it's not worth the installation costs and the running costs and having AC. Like literally nowhere in the UK, like shops and malls and stores and stuff will have it, but no one has AC in their house. No one has air conditioning indoors. It's super, super unheard of. The other issue I get is that when I have the window open this time of night, with the extremely bright lights in here, man, the bugs, they fucking love it. They come in here like it's the sun. They get attracted to this window. Right, okay, they're in there. So now let's power the board up again and let's see what we have with the voltage regulators in there. We should have our plus minus 15 volts, provided that there are no further issues on the board. So what I'm going to do is I'm going to power it up quite sort of slowly and cautiously. I'm going to turn the current way down. If I give you the scope screen, I'm going to turn the current way down from 4 amps to the 1.5 amps. That should power this up real slow. And what I'm going to do is probe the op amps over here. I'm going to take a look at pin number 4 for a start, and we're going to see whether we get plus or minus 15 volts on that one while it's trying to power up, and that will tell us a bit about whether there's any further issues on the board or whether there's any issues with the voltage regulators, etc. So let's give it a bit of power. Let's see what we have. Okay, no, we don't actually get, we have like minus 1.8. What do we have on pin 8? Again, about 1.3 volts. So yeah, it's not actually able to build any voltage at all there. What do we have on the rails? Is it building rail voltage this time? Yeah, it's building rail voltage pretty slow. I have turned the current right down. We still have that big swing to negative. Look, we still have that huge swing to negative rail on the outputs. That's the low side drain I'm probing right now. Every time I pulse a remote, we get a big swing to negative rail. So we still have the same issue as before. But what I'm going to do now is I'm going to take my thermal imaging camera and see whether these new regulators that we fitted are heating up. See what's going on. Hear that train? So they're going to be a bit hot anyway because we just soldered them. So we got, what is it, 31 degrees Celsius. So let's turn the amplifier on and let's see if they get super toasty or not. Oh yeah, 52, 63. So they're still getting super, super hot. Still drawing some current. Now I did notice there was some other parts on the board over here that were drawing some current actually. Oh, there's something over here. I've got a couple of pull-down resistors. They'll get kind of hot. That's fine. That's normal. Now there is this op amp over here. Now you see this hot spot on the board over here. Okay, you see this hot spot on the board over here? That is right in the location of this op amp here. So this is kind of turning into a bit of a hotspot on the board. So I'm wondering whether that op amp has failed and is causing excessive current draw, which would be heating up these voltage regulators. These voltage regulators, yeah, they're cooking right up to like 70 degrees Celsius in like a few seconds over here. And these two are now obviously the plus minus 15 volts. So what I'm going to do is I'm going to remove this chip from the board, this op amp, and see whether the current draw goes away from those voltage regulators. So let's take some flux. Let's flux her up. I'm glad I decided to look at this one. This one's been fun. It's a little bit different, you know? It's a little bit different to your standard kind of FETs and drivers, FETs gates drivers that I do every fucking day for like the last 6 or 7 years. Are you sure that 317 and 337 are in the right place? No, I'm not sure. I'm not sure. Because I've had quite a bit of wine and I'm not paying too much attention. Let's have a look. Let's just see whether they're in the right place. So what have we got? We've got the 337. Okay, we've got the 337 in the location which is connected to pin 4. So pin 4 of the op amp is supposed to be negative voltage, VCC negative, pin 4. So we have the 337, which is the negative regulator connected there. We have the output on pin 3. So yes, even though I have had a bit of wine and I don't really give two fucks about this amplifier anyway, it seems that we do have the voltage regulators in the correct place. Okay, cool. That should be cooked up enough now on the old Stanker Ruby. Take some tweezers. Where's my hammer? Where's my tweezers? There we are. Let's remove this because this is getting hot. So I'm just going to pull this off the board temporarily, like so. And with that off the board, we're going to power it up again. And what we're trying to do is we're trying to get to a point where plus minus 15 can build properly. At the moment, they're not building at all. They're just shorting out, and we're drawing a whole bunch of current. So we want to get to the point where plus minus 15 build reliably and smoothly. So now that we've removed that IC, let's power the board up again and see if we get some plus minus 15 going on over here. Probe pin 4 of the op amp. Oh, there we go. That was more voltage than we ever saw before. Let's turn the current up from 1.5 amps to 4. Hey, my man! Look at that bad boy! Skir, boom! We have minus 14.2 on that pin 4, and we have plus, oh, it's a bit uneven, plus 13.6 on the positive. The plus minus 15 doesn't have to be super equal. Like, it doesn't have to be exactly plus minus a mirror image of itself, but there's a little difference there. Okay, so with that op amp that was clearly causing a short removed, that was this bad boy right here. Let's see. So now that that's removed, we should have lost our swing to negative rail on the low side of this. Yes, we have. No more swing to negative rail on that right there. That's excellent news. So I think that we probably just need to go ahead and replace this op amp that we just removed, and this is looking like an LM393. So yeah, LM393. Let's find a new one of those and drop one of those in to this location right there. See what that does. Where would I find one of those? Might have one in here. .211 2072C. Actually, you know what? I think I've got some 311s on some spare donor driver boards. Might be quicker just to grab one of those off of a donor board rather than trying to fish through this tray for parts. Got some 311s, 311, 311, 311. Yeah, it's probably just going to be quicker to grab one off of a donor card. So let's grab a donor card off of my racks up here. Oh. Where are we? Here we go. Some donor cards in here. Let's find one that's looking particularly jank. Oh my goodness, that looks jank. Look at the state of this one. Look at the state of this driver card. You've got like all kinds of jank stuff going on over here. Got like missing massive hole in the board, jumper wires, all sorts of shit going on there. Now, is there a 311 that remains on the board? Sorry, a 393. Yeah, 393. Shit. These are all masked. I can't remember which one's the 393. Actually, I don't know if any of these have the 393 on them. Fuck, we could be straight out of luck. I don't think these cards use a 393. I think they use a 311 2903. Shit. Oh, I've got a 293. Is a 293 the same as a 393? And is that the same as a... Are they compatible? Hang on. Right, let me look up some data sheets. What's this? LM2903. I'm going to do this myself, guys. Is it LM2903? Here we go. LM393 and 2903. Also the 293. Okay, these are dual comparators. So what's the differences then? Are they going to be interchangeable? Let's see, part number 393 to 903B, yeah. So what is the difference here? The supply voltage for the... So the one we need is the 393. The 2903 has the same supply voltage, temperature range. Oh fucking hell, that's literally the only difference. The 2903 is the same as a 393, but it has a higher temperature range. Well, fucking hell then. Alright, sweet. So, what's the... One of these driver cards has a 293. The 293 is all the way over here. Slightly less supply voltage. Slightly higher total supply current. Different temperature range. And lower ESD handling. Okay, cool. So I think the best one to go for is a 2903. So let's grab one of those. I think the jankest board that we have that we can go from. Let's have a look what we got. 2903. I want to pick one off of like a really jank board that's like missing most of its parts. Here we go. That'll do. Bye bye, my friend. Bye bye. Hooray! Shove that on there like Tony Blair. Okay. Alright, so provided all is well, when we power it up now, we should still get our plus minus 15, and we might get some more activity in the output section. We shouldn't. I'm hoping that we don't get a big swing to negative rail again, like we did before. So let's put one probe on the. Let's take one probe here, a spare probe on channel 2, and let's latch that onto low side drain. Okay, we're going to go to our scope and we're going to go to channel 2, turn channel 2 on, 20 volts divide, and we're going to choose channel 2 as a source so that it latches to the frequency of low side drain if it switches. We're going to use probe number 1 for checking our plus minus 15 volts. So let's do that. Probe 1 on pin 4. Let's give it some power, see what happens. Scary moments, like a little bit scary, you know. This isn't a big amplifier, but I want to see what happens here. Oh, fucking hell! Oh my days, lad! Look at that! Fucking, yeah, man, there's really output switching. that's the Lewis Rossman fan spin. That is. Fucking, yeah, look at that bad boy! Fucking parts amp, spare parts amp. Got this spare parts amp up and running, didn't we? Fucking yes, look at that. That's fucking switching. That is. All right, who wants to see that making some bass in? Should we get a little sub that I fixed up recently and plug it in? There we go. Here we go, gents. We've got some. Hang on a minute. Fucking. Right. Well, look at this. We've got some. Here we go. This is a diamond audio. Little 12-inch. It's a single 4-ohm coil. This is the Diamond D1 12D4. Oh shit, it's a dual 4-ohm, my bad. I thought it was a single 4. It's a dual 4-ohm, and this had the surround separated from the cone that I just quickly fixed up. So, let's just plug this in to this amplifier that we just fixed and show you it playing some bass. This got all the fucking grub screws in the terminal. How has this amp still got all its grub screws in the fucking terminal? Like, I thought I would have stolen by now. Now the problem is, gents, is yes, although we just fixed this amp isn't probably ever really going to get used like too much, because this amp was in the parts box as a spares amp, because, well, it's missing all its fucking bits. It doesn't have any end plates, it doesn't have a back plate, it doesn't have any MOSFET clamps. Like, it's missing basically fucking everything. So, you know, I'm never going to be able to sell this. Yeah, it's never going to be installed in a car again, probably. But I could use it for some fun experiments. We could do some fun shit with it, who knows, you know. Alright, so here's my little sub. Now let's put some RCA signal going in here. Let's just get up my frequency generator, plug in the RCA. Now I don't know which one of these RCAs is input, because I don't have the end plate, so I'm just going to have to make a cheeky guess. I'm going to guess it's this one. And I don't know what any of these knobs do either, because we don't have the end plate. So I'm going to guess, shove all these to 0 for now. Actually, oh fuck, wait on a minute, what's that? If this is a mono amplifier, why do we have 6 sets of outputs? Okay, maybe input, output, slave in, master out, perhaps? Maybe? I don't fucking know. Alright, well let's turn all the knobs to 0 because one of them is going to be gain, so I don't want that to be up when I'm testing this out. Let's put the frequency generator down to 32 Hertz with a nice low signal to start with. Let's put our probe on low side drain again, just for jokes. Why not? Just for shits and giggles, so we can see it on the scope screen. Turn my soldering rod off, don't need that anymore. Okay, cool, let's power up and let's see if we can get some bass out of this thing. Oh shit, oh it just broke again. Hang on a minute, what the fuck? Oh no, it's working, never mind, I had my probe messed up. Alright, sweet. So, okay. I can feel some bass, Yeah, here we go. Hey! Look at that. Now, which one of these bad boy switches is gain? Not that one. Not that one. That one maybe? Oh, that one. Ta-da! Yeah, boy! Look at that duty cycle. Look at that modulation. Look at that Class D modulation. If you ever wondered how Class D works, well, that's how Class D works, my friend. I done a whole live stream on how Class D works. As part of the streamer series, I did a whole live stream on how Class D works. And if you gentlemen and lady are following my audio pipe modification video, then there is a good segment of that video that actually kind of goes into how Class D works a little bit, because there's some really fucking interesting stuff. Dude, that video that I'm doing with the audio pipe modification, that has got some seriously awesome, cool, in-depth shit in that you'll see soon. I've been working my ass off on that video actually. It's going to be amazing. It's going to be super long, super detailed, loads of stuff, loads of... I even did some animating. I even animated some stuff for it, so it's going to be amazing. It's going to be super good. I'm just going to check the live chat right now. See what we've got going on. Yo, hey bro, how much money have you made fixing amps? I don't know, man. It's been like, this is my only job. This is my full-time job. My full-time job is fixing amps. So I have been able to support myself fully, financially support myself fully from just fixing amplifiers for, I don't know, 6-7 years, maybe, something like that. I now have a new house. I run 2 vehicles. I have DDZ4s. That doesn't mean anything, by the way. Anyone can buy DDZ4s and have no money left in their bank afterwards. So it's doing alright, you know. I can support myself comfortably from amplifier repair, so it's alright. However, I would say that it's only possible because I'm the only guy in the UK really doing this, like reliably all the time. If there were like, if say 3 or 4 other guys in the UK were to pop up and start repairing car amps, then I wouldn't be able to do this for a living. I would not make enough money if it was spread out over 3 or 4 different people. I'm really the only guy doing this in the UK, like car amp stuff, specialising in car amps. And if I wasn't the only guy doing it, then I wouldn't be able to support myself. Yeah, man. Jesse says, nice. Yeah, thanks. Nice. Very nice. I like. How much? Great success. Yay, it makes bass. Yeah, it does make bass, my friend. And even though it's a stanky ass precision, no, sorry, it's a power acoustic, the circuit design in this is actually not too bad. It's actually quite nice little circuit design. Relatively modern, pretty high efficiency, I imagine. Nice components used. Yeah, that's not bad. It's alright, an amplifier. Same as a Sundown, just much cheaper. Sundown actually did use this same circuit design, so that it is the same as a Sundown. And it will sound fine, it will sound great, it will sound fantastic. My JBL passive radiators are rocking. Do you speak Espanol? Not really, a little bit. Sam, have you competed in SPL? Not yet, no. SPL isn't really a thing in the UK. The UK has a very small bass scene, okay? And the bass scene that does exist doesn't give a fuck about SPL in the sense of dB drag and all that shit. The main class, the main competition in the UK is proper droppers, which is completely different. It's all low frequency and it takes a average of dB scores across a range of frequencies. So you can't just build a Burt box for the UK bass competitions. You can't just build a one note wonder. You've got to build something that plays flat from 20 to 40. That's how you win in the UK, which is great because it makes it amazing for music. The whole UK bass competition scene forces you to build a system that fucking plays music, and it's awesome. It sounds great. Bevis, have you ever seen rail caps fail? Very rarely, like once a year or maybe once every 2 years, in fact. Very rarely. Actually, I can't even fucking remember last time I saw a failed rail cap. It must have been over 2 years ago now. Jesus. Yeah, a long time ago. Rarely ever see rail caps fail, honestly. Scrape and bass. Thoughts on the Sundown Soul amps? They have great potential. However, they are ruined by electromagnetic radiation emissions control, so like regulations. So the power supply is switched very softly with high value gate resistors to get through the regulations, and that does limit the amount of power the power supplies can handle. Secondly, the output MOSFETs which they use generally are not the best. They're very slow. There's cross conduction. They don't heat evenly. There's all kind of uneven heating or idle, uneven current sharing between MOSFETs in the output section. They're a great idea, and the basis is there for a fantastic amplifier, but there's a few things that let them down. That means that I wouldn't run them, and I see a lot of them fail really badly. And there's no fucking protection against the power supply exploding if there's an output section failure. Fucking pisses me off, man. This is what the Brazilians are so good at. They're PIC controlled amps. They have a fucking health check mode, and it prevents this bullshit nonsense of the power supply failing every time the output fails. Is Big D Wiz visiting you sometimes? No. Big D Wiz is in the States, I'm in the UK. Given the current world situation, I don't think that kind of travel would be allowed anyway. And also, it would probably cost him a fucking bomb to get over here anyway. I'm doing a collaboration with Big D Wiz at the moment with the Audio Pipe mod video, which is going really well. Maybe I'll give you guys a sneak peek. So yeah, I'm working with Big D a little bit at the moment. Oh, what flux do you recommend? This is really fucking important. Oh no, I took the fucking label off. Urgh. Bugger. Hang on a minute. I'm going to try and find the flux that I use. This is really important, guys. If you're doing electronics repair, flux is really important. And flux is really important. And it's a godsend. But having the right flux is important. You can get so much flux online that is conductive, which is completely counterintuitive. You don't want conductive flux, and trust me, I've been there. I've got a pot of flux sitting up here that's freaking conductive, and it causes all kinds of bullshit. Don't use it. Nightmare. The best flux I've ever found, I'll try and find a picture of the label because I removed, for fuck's sake, I removed the label. I took a picture of the label. I'm trying to find it in my Google Images, but I don't know if I'm going to find it. I might have to search my mail. If you want to know what kind of flux to use, send me a message on my Bearvids Facebook page, and I will search my inbox and try and find the flux that I ordered, because it's the best shit in. Yes, I think it might be Chipquik. It might be Chipquik, but I can't remember what model it is. What are you planning to do with the DDZ subs next? More power, upgraded coils, spiders, etc. says Mike Honda. So the DDZ4 subs that are in my van at the moment, which I'm going to make a video on very shortly. I'm just waiting for the weather to get a bit better. It's raining and shit. They are in the build in the van, okay? As you have seen in my videos, I've done videos of them doing hair tricks, blah blah blah, they're nice and loud, etc. So at the moment, the limiting factor in that build that I have in my van that prevents it getting any louder is subwoofer mechanical excursion limit. So the way that the build is done at the moment is my limit is the mechanical excursion. So I can't go any louder because the subs are at the mechanical limit. So adding more power isn't going to do fuck all. Adding bigger, better coils, spider, blah blah blah, not going to do anything. The only way I can get louder with my current setup is by changing the box, like modifying the box. I need a smaller low side. It's a 6th order, right? So I need a smaller lower side, low side chamber. I need more port area, and that will help me get louder because I need to hold the cones stiller. I need the cones to be loaded more heavily by the enclosure so that I can add more power into the subs to get them louder. At the moment, adding more power just breaks my subs. Like if I try to add more power, I just rip them to pieces. They are already on the mechanical limit. I think they're doing about 155, 156 dBs at 25 Hertz, which is not bad for a pair of 15s, but they are stone cold. They do not heat up, and there's a shitload of impedance rise, which means if you've got a shitload of impedance rise and your subs are staying cool, that means your box is probably too big. Which it is. The low side chamber is too big. I don't have enough port area. So in order for me to get louder, I need to shrink the low side, add more port area, then it will be louder. Your thoughts on Pride subs and amps? I haven't seen Pride amplifiers, but their subs are pretty fucking awesome. Yeah. Oh, what the fuck is that? Big ass fly bug shit thing. What are you doing? Making some crazy noise. Jesus Christ. Pride subs are badass. Like, they are industrial monsters. They're not nice sounding. Well, they'll sound fine. You can't really say nice sounding from a subwoofer application, but they're not like super smooth, beautiful like subs. They are just raw, power-hungry monsters. They are inefficient as hell, but they don't fucking care. They will take power. They want power. Power is cheap these days. You just got to give it power, and they will lap it up, and they will get fucking loud. They are awesome. Really, really cool things. What's your thoughts on the Sundown SIA 3500 compared to the Times? So I haven't actually seen the Sundown Intelligent Amplifier SIA. Haven't seen the circuit design. but I imagine it's probably very, very similar circuit design to the Smart 3. Now, don't get me wrong. Okay, Sundown, they have made some fantastic products in the past. Sundown subwoofers, for example. Sundown are known for their subs. Okay, their subwoofers you can't buy anywhere else. Yeah, if you want a Sundown sub, you have to buy a Sundown. Okay, the same goes for Digital Designs. If you want a Digital Designs sounding type of sub, you have to buy a Digital Designs. You can't buy a Digital Designs sub anywhere else, because that's what they make. They make bespoke, unique subwoofers, same as Sundown. Okay, the problem is that because these brands are now very popular and big, they feel like they need to offer a range of other products to work with their subs. So Digital Designs, for example, also, in addition to making subs, that's what they started out making. Digital Designs got big and got known and became a brand for their subwoofers, and still are unique bespoke subwoofers. But they also offer to the customer amplifiers, door speakers, DSPs, crossovers, blah blah blah, la di 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 blah blah stupid. So they offer the whole range of stuff. So you can basically run a full DD build. Same with Sundown. You can run a full Sundown build. But Sundown and Digital Designs don't, and Ground Zero and all the other B2 and all the other brands, they don't do any in-house R&D. They don't, a little bit maybe, but they don't design their own circuits. They don't in-house design a circuit from scratch for their amplifiers like they do for their subs. So Sundown subs and Digital Design subs, they are built up from scratch, from dust. They're nothing, and they are built in-house and designed in-house from nothing to be solely and purely and only that thing. You can't buy a Digital Design sub from any other brand. Like, it's not a Digital Design sub. It won't sound like it. It won't perform like it. The same for Sundown. But you can buy a Digital Designs amplifier from another brand and have it be the almost exact same circuit. Like, the same for Sundown. You can buy a Sundown amplifier from a different manufacturer and it'll be the exact same circuit. They don't make their own amplifiers. That doesn't mean that they're not good amplifiers. Sundown and Digital Designs and many other brands, B2, Ground Zero, etc., all those brands have had very, very good amplifiers in the past. You're a big motherfucker. But they're not designing their own amps. If they were designing their own amps in-house, then their amps would look a lot different to how they do. This is where the Brazilian stuff comes in. The Brazilian brands are employing circuit design engineers to make them a brand new amplifier from scratch, using modern parts that are available, modern drive circuits, efficient technology, new stuff. That's why the amps are all so small and so efficient and do so much power, because they're all just built from scratch based on modern parts and modern technology. Whereas, like, a lot of the old Korean half-bridge stuff is all like 20-year-old circuits that are just regurgitated because no one can be bothered to pay for a circuit design engineer because it's expensive to do that, whereas it's cheap in Brazil to do that. It must be cheaper to do that in Brazil. So, yes, I like what Sundown are doing, I like what Digital Design are doing, I like what many brands are doing. But if you're asking me what amplifier to buy, I am generally never ever going to recommend you an amplifier from any of those kind of brands, because they aren't those brands' own amplifiers. They are a twist or a take on, or just a literal generic cookie cutter amplifier from a factory that won't necessarily be optimized and perfected. Right, these factories, they have a catalogue of these board designs, and you can change a few parts here and there on them, but they won't be optimized. They won't be. There hasn't been a guy that really loves his job that sits down with this circuit design and wants to extract every last bit of efficiency and every last bit of wattage and power from this board and make this amplifier perfect. They don't fucking care about that, those factories. They don't care about that. They just care about turnover, mass production. How many of these things can we get out of the door? How many brands can we sell this circuit design to? Whereas the kind of guys that are designing the amplifiers for the Brazilian brands, which is why I have a high respect for them, like the Taramps Smart series of amplifiers, that's a unique, bespoke circuit. No other brand has that circuit design. It is solely Taramps. And they did it first, and they have a guy that's designed that, that's poured his heart out into that circuit design to make it as good as possible. The reason that a lot of people don't like the Brazilian amplifiers is because the Brazilian amplifiers are designed for the Brazilian market. That's the thing that people don't understand. The Brazilian amplifiers are designed for the Brazilian market, not for how you want to run it in the States and how you want to run it in Europe and stuff like that. That's why they don't work so great, and they haven't worked so great in the past with the original Brazilian style of amplifier. The Brazilians are now catching on to that, and because they're selling to overseas market, they are producing amplifiers that work for how we want to use it over in the West and stuff, like the Taramps Bass series and the Smart series and other stuff like that coming from these Brazilian brands. They are making amplifiers that specifically are tailored to how the Western market wants to run them. Whereas with their original stuff, it was designed for the Brazilian market for full range, high impedance rise, high efficiency, transient, higher frequency, mid-rangey, mid-bassy, kick-bassy kind of stuff. And that's why they generally don't really work so well on low efficiency, low impedance rise, long drawn-out sine waves, sundown or unheat CCA bullshit subwoofers. Anyway, going back to what I was saying, if you want to choose between the Sundown Smart Intelligent Amplifier and the Taramps, I will always tell you about the Taramps, because that was the original, and the Sundown is probably based on the Taramps, but it will be like a Chinese copy. The same way. Fucking hell. The Sundown Fullbridge SFB and the B2 Riot and the Ground Zero GZC, or whatever it is, GZCA, and the Def Bonds newer Fullbridge amplifiers. All of those fucking amplifiers, none of those companies did any R&D. They went to China, they said, what Fullbridge designs have you got on the catalogue? And the Chinese factory that they've gone to have copied the Sound Digital circuit design. So if you buy any of those amplifiers from any of those brands, Sundown SFB, B2 Riot, Ground Zero GZCA, Def Bonds, I don't know what the fuck they call it, any of those amplifiers that are Fullbridge, you're buying a Chinese copy of a Sound Digital. Just buy the Sound Digital, for fuck's sake. Don't buy any of those. If you want to buy a Ground Zero amplifier, buy one of the old Koreans, because they have more of the bugs ironed out and they're more reliable and they're solid amplifiers. Same as a Sundown. Buy a Salt. Yes, it's not perfect, but it's still a fucking monstrous amplifier. If you're buying a digital designs, buy an M series. If you're buying a I don't know, Def Bonds are fucking bullshit. They don't do anything of their own anyway. But don't buy the cheaper if you're going to buy an amplifier that is designed in-house by that brand. Yeah, if you want to buy the best subwoofer on the market, buy a subwoofer from a brand that makes subwoofers. Digital Designs, Sundown, Ground Zero to an extent, and stuff like that. If you want to buy an amplifier from a brand that just makes amplifiers as their main thing. Paris, Taramps, Alpine, fucking sick amplifiers. Alpine make some of the most crazy, bestest, next level modern circuit designs on the fucking market. Amazing shit. JL Audio, complete bespoke in-house circuit design. Buy one of those. Don't buy an amplifier that has your favourite brand logo on it just because it has your favourite brand logo on it because it matches your subs, because yeah, that amplifier might have your favourite brand logo on it and the subwoofer that you buy from that brand might be sick, but the amplifier is not necessarily that good. You'll generally find that, like, even going way back into history, at audiophiles that would buy hi-fi separates back in the freaking like 70s, 80s, 90s, whatever, you know, with a big stack hi-fi separates. People that were really into hi-fi, they would never buy a stack of hi-fi separates from the same brand. That's what the noobs did. That's what you buy from the fucking Walmart. That's what you buy from the, you know, the shop that just sells you a stack of, you know, an all-in-one unit. As an audiophile, as a hi-fi enthusiast, you would buy the piece of equipment that's the best thing from the manufacturer that just solely makes that. So you would buy the phono record player from the company that just makes record players, that makes the best fucking record players in the world, and that's all they make. and then you would buy amplifiers from the company that just makes amplifiers. They just make sick amplifiers, and you would buy like tape decks or whatever. You'd buy the piece of equipment from the company that is good and known for making that specific piece of equipment. Your brands don't have to match. The mismatched brand system is generally the best system you can have, because you've bought individual pieces of equipment from the brands that specifically make that piece of equipment, and therefore you've got the best from each of them. Rob, dude, thanks for the 20. I got a landline phone. Hilariously, I don't actually have a landline phone at this new address. Who has a landline phone these days? I don't know anyone that has a landline phone these days. DeMoor Engineering has some of the best currently of amps available for sound quality. I do not deny that. I haven't personally seen or worked on, or I don't know anything about the DeMoor range of amplifiers. However, Mr. DeMoor is a fantastic circuit design engineer. He really knows his shit. He knows what he's freaking doing. So if he's going to design an amplifier, he's going to design it from scratch, and it's going to be proper. So yes, he hasn't gone to a factory in Asia and said, what circuits have you got available? Make a few tweaks here, put some more MOSFETs in there, put some more caps in there, and call it a day. He's designed a circuit from the ground up to be something special, something unique, something based on current technology. So for sure, I don't deny that they're probably amazing amplifiers. Question, Bevids. 400 RMS 400 each max. What? Question, Bevids. RMS 400 each max for two 12-inch Eminence stubs stereo for my IS300. What should I buy? I'll be running it with a cutoff in mid-bass range. Mostly rock and roll type music. What should I get? Are you asking me what amplifier you should get? I would. There's some nice efficient sounding Eminence subs. Probably there's some nice efficient PA subs. I'd probably run that on a Class AB, to be honest, because you're going to be looking at getting some higher frequencies in there, getting into the kind of kick bass directional kind of frequencies. I would probably look at something Class AB, maybe a B2 Audio, one of their Class AB high power amplifiers would sound really nice on those. Just me says no company does it all best. Absolutely correct. If you're running a system that is all one brand, then as cool as it might look, it kind of says that you haven't really done your research into the best pieces of equipment from each different manufacturer. You've just kind of gone, I like this brand, let's get everything from this brand. And there might be some brands that have great subs and great amps and stuff like that, but they won't have the best everything. I mean, there's a couple of brands that have really good loads of stuff. A couple of brands that come to mind are JL Audio. It's expensive, man. Fucking JL Audio is fucking expensive. But you are paying for bespoke stuff that you can't get anywhere else. Like, there is nothing else out there that's similar in design to the JL Audio stuff when it comes to amplifiers or subs, really. I mean, a sub's a sub. It's a coil and a magnet and a fucking piece of rubber and shit. But, the JL subs are unique. The JL amplifiers are very unique. So there are a few brands that you could buy a lot of the stuff from, and you would actually end up with some pretty nice equipment in your system. Alpine, again, are considered as to be like a kind of budget brand. Like, you don't really consider Alpine to be like a super high end, but because they're such a big company, They have some amazing genius guys working on the designs not only of their electronics but of their drivers as well, man. If you go on YouTube and look at some of the internal meetings and the internal kind of showcases that they have of their subwoofer design concepts and stuff like that, the kind of technology that's going into their drivers is really, really, really amazing. They're getting really high power ratings out of tiny coils and efficient subs just through really clever cooling methods and heat dissipation and stuff like that, and shallow mount stuff. It's really, really clever engineering going into Alpine stuff, not only in their amplifiers but also in their subs. Yeah, in the real world they don't take a bunch of abuse. The raw materials of the Alpine subs, they tend to kind of fall apart a bit if you give them too much abuse. But the amplifiers are absolutely phenomenal. Alpine amplifiers are well ahead of their time. Alpine were making full bridge, Brazilian if you want to call it that, style amplifiers 10, 12 years before everyone else caught on. If you look at the Alpine MRP, I think it's the MRP M2000, that's basically a fucking bander inside. But it's awesome. It is brilliant. Have you heard of BMS speakers? They make subs, mid-high compression drivers. Yes, I've heard of them, but I'm not massively in the kind of PA kind of scene. I don't really keep up with PA stuff, so I'm not too familiar with, you know, the range of products. I haven't personally really heard much of their stuff. Oh, what about Rockford Fosgate? Yes, sorry, that's another brand that I often forget to mention. Rockford Fosgate, again, are bespokely making a lot of their stuff. They have in-house circuit design engineers that will build them a circuit from scratch. You can see that by looking at their amplifiers. MTX, again, have made some circuits from scratch that have been really, really fantastic for their time. Kicker, again, make all their shit in-house from scratch. Say what you like about Kicker, man. There's so much bullshit online about Kicker being good or bad or whatever. Some people love it, some people fucking hate it. But whatever you say about it, they are not doing you a stupid silly by just buying mass-produced cookie-cutter generic shit from China. They are actually bringing you a product that is bespoke. And I have respect for that. I don't necessarily think I wouldn't necessarily run Kicker myself. I mean, some of the stuff I don't know, I might do, but you know, whatever is what it is. But I have respect for Kicker because they are bringing their own shit to the market. They're not just a label that's sticking their brand on a generic circuit. They are bringing their own shit to the market, which I have respect for. Rockford Fosgate, right? If you were to ask me now, what is the best subwoofer on the market? What is the best subwoofer in the world right now? You might think that I would say Digital Design's Z4. And it's close. The Digital Design Z4 is a close second. Only beaten by the Rockford Fosgate. I can't remember the exact model number. But it's the sub that they call the 19-inch. And it's a really bad name. I don't quite get why they called it that. Because by calling it the 19-inch, they actually mislead a lot of people that are considering buying that, or, you know, potentially in the market for that, maybe have the budget for that kind of sub. Because it's actually a 21-inch sub. Yeah? Rockford Fosgate, whatever it is, 19 fucking... I can't remember the model number. But the ridiculously expensive flagship Rockford Fosgate subwoofer that they call the 19-inch, it's 19 inches of piston diameter. It's a 19 inches of cone area. The actual subwoofer is a 21-inch, and the size of the sub, if you measure the sub frame, you know, it's the same or bigger than all of the other 21-inch subs offered by other brands like the Stereo Integrity. I think they make a 21. Digital Designs 9921 or Z3, Z4 21. B2 Audio 21 inches. Def Bonds 21 inches. The Rockford Fosgate 19-inch is actually the same size or bigger as all of those 21s. So it's a 21 inch. So if you have the money for the best subwoofer in the world right now, that Rockford Fosgate 21 inch 19 thing, injection molded cone surround thing, edge wound 5-inch coil, Neo motor, I think it's a split motor design, a bit like XBL2. Dude, that thing is absolutely unparalleled. There is nothing on the market that compares to that Rockford Fosgate sub that I'm aware of. I went to Australia, as some of you guys might know. I did the Bevis Down Under series, which hasn't really got that many fucking views. I'm a bit pissed off about that. I might have to rename some of those videos. Some of the best content I think that I put out is from my trip to Australia, where I did the Bevis Down Under series, and in those videos I showcased Brad's 4 21 inches. He has 4 of those Rockford Fosgate 21s in a 6th order, and that is by far not only the loudest, not only the windiest, but the cleanest, tightest, punchiest, most pleasant to listen to sounding system I've ever heard. Even more so than my Z4 15s, even more so than any other sub system I've ever heard in my life. That system fucking walked all over everything else. Absolute, I just can't put into words how that sounded. It wasn't just loud, it just sounded incredible, so listenable. So that is the best sub in the world, in my opinion. And if you were to say to me with no budget whatsoever, Bevan, what sub should I get? Straight away, Rockford Fosgate T whatever it is, 19, 21 inch thing. T319. Have you heard of Sony's new ES series? Gear should be all-encompassing in terms of products. I haven't actually seen any new stuff from Sony. I would be curious to check it out though. I haven't seen any new stuff from Sony. I haven't checked it out myself. Scar does fall into the category of off-shelf design subs and amps with cheap parts. Yeah, Scar is a brand that is offering your kind of generic cookie cutter products from these kind of Asian factories and stuff. It's doing that, but it's not pretending. It's not pretending that it's making its own stuff. You know, the stuff is cheap. It's priced accordingly. So yeah, if you're buying Scar audio stuff, you're not buying anything that any guy has sat down. You know, no one at Scar has sat down and designed this sub or designed this amp. They're just a business. Yeah, they're just a business, and they buy stuff in bulk and put their logo on it. They might make a few tweaks. They might say to the factory, "Oh yeah, you know, make this a specific level of like goodness," or put these, you know. The factory might say, "Oh, we got, you know, various levels of quality or various levels of assembly quality that you can have here." So they're not designing anything, but I don't think they're pretending to. They're offering this stuff to the market pretty cheap, and so you get like reasonably good quality, mass-produced cookie cutter stuff at not too expensive a markup. Yeah, you know. So for budget stuff, use it correctly. It's going to sound fine. I think Dimore designed Steve's yeah, absolutely. So Steve Mead, yeah, he knows a fair bit about audio, but Steve Mead doesn't design circuits. So yeah, the Dimore company designed the circuits. They designed the DD1 and all the SMD equipment. And the Steve Mead, the SMD, is just a branding to sell it by. So Steve didn't design those. He's just a kind of marketing figure to sell them. So what are we looking at now? You might hear the sound of clips undoing themselves on my workbench. I'm not actually too sure why I'm doing this. What is this? This is a Lanzar. This is a piece of shit. This is a Lanzar OptiDrive 1000D. Now, I have no idea what's wrong with this, because this has been in my workshop for absolute years on the back burner. Does it have dead output FETs? You can see the numbers there on the screen. Okay, yeah, it does. It has dead outputs. Okay, alright then. Let's just quickly bang this off here. Now this right here, this amplifier circuit design is the kind of amplifier that I will generally turn away. I would not really recommend spending too much time trying to repair this style of amplifier. It is, at this point in time, beyond ancient. It is really, really old technology. This is a completely discrete Class D drive circuit using only transistors, like big through-hole transistors, to form the drive circuit of this amplifier for the Class D circuit. And the parts on this driver board, the tolerances of the specifications of these parts, of these transistors, are so tight that if you were to replace all of the transistors on that driver card with the same model transistors, you know, brand new ones from the modern age, the driver card probably won't work. Excuse me. Because it's kind of on the fine edge of being stable with the tolerances of the components at the time that it was built. So now, many years later, yes, you're buying the same part number, but the actual specifications, the actual, you know, tolerances of that part will be different. And I've found that a lot of the time, rebuilding these driver cards doesn't work. It just they fail to work at all. So with these kind of amplifiers, if you have a dead driver card, if you've got one of these driver boards that doesn't work, then you're kind of out of luck, you're kind of stuffed. And generally they're used in cheap, shitty amplifiers anyway, so a lot of the time it's not worth spending a bunch of time on it. Yeah, so with these amplifiers, if you have a dead output section and changing the FETs doesn't fix it, then you might as well just stop there and throw it away. Because even spending hours trying to fix a drive circuit, you're not going to end up with a successful repair. Any amplifier repair techs in the live chat, I would love to hear from you. If you have actually successfully managed to repair a damaged drive circuit of one of these type of boards, let me know. I'd be really interested to hear your experiences with that. Wow, okay, so this amp has failed from vibration damage. We've got snapped legs on the output MOSFETs. So in that case, we do need to fully disassemble the board. I was going to see if I could get away with a top board repair on this piece of shit, but I don't think we can. I think we're going to have to take it out of the heatsink. Where's my hammer? I thought the OptiDrive series were good. Lanzar OptiDrive used to be good back in the day, like fucking years ago. And that's when these kind of circuit designs were not that old. The original Lanzar stuff, you know, it was American stuff, it was proper. And yeah, that's when these circuits were like the kind of current thing. Problem is that Lanzar never moved on. And they got bought out, and it's all Chinese really shitty, poorly assembled bullshit that you can buy off Amazon now, like mass-produced crap. And yeah, it's just terrible now. Nowadays, modern Lanzar is fucking horrendous. Don't buy it. It was good back in the day when it was all built properly, and when the circuit designs that they were using were current for the time, but they haven't moved on. And I guess they've been bought out, but the modern Lanzar stuff's all made in China to like the worst quality specs you can imagine, the worst build quality standards you can ever imagine. So yeah, they're pretty fucking bad. Don't buy them. So I'm just going to take a quick look at this. I'm not going to spend too long on this because it's gone past midnight now already in the UK. So I'm just going to take a quick look at this, and then I'm going to shoot off, get some sleep, I reckon. Fucking hell, the amount of flies in here is mental. Tiny little fruit flies. Tiny little things. Because I got my window wide open, and the bright inspection lights in here, they attract all of the bugs. I love it. £20 25 hertz to life says, is a kicker warhorse any good? So I spoke about that in depth earlier on in the live stream. So if you want to learn about the kicker warhorse a little bit, firstly go and watch my video that I did on the kicker warhorse. I did a really long in-depth video of how it works, and in this live stream earlier I also went into quite a lot of depth about whether it's any good or not. Lachlan McDonald says, which would you pick, Banda, Tarams or Paris? Without a shadow of a doubt, Paris. Like, the circuits and the build quality are like so far ahead of anything else that I've seen. Absolutely freaking brilliant. Also, Zapco, heard a lot of good things about that brand. Oh boy. I'm sure Zapco makes some good stuff. Fucking hell, but the... what is it? The 2000? I can't remember what the model number is. I repaired 3 of the 2000 watt RMS Zapco amplifiers recently. They sell for like £700, which is like $950 or maybe even $1,000. I don't know what the conversion rate is for like a 2,000 or 3,000 watt amplifier, and that shit is the same bullshit junk that you'll find in loudest.com, Audio Bank, Bassface, like literally Audio Pipe. It's the same fucking circuit, and the build quality isn't even that good either. So I think Zapco probably have made some nice stuff, probably do make some nice stuff, but I think some of their range of amplifiers that they're releasing are a quick money grab at the minute, and they're using their brand status to kind of sell shit amps at a high markup. So I would advise you to strongly avoid Zapco for the time being until you know a bit more about what you're buying. Okay. Yep, vibration damage. As you can see here, we have these MOSFETs with their legs snapped off the board. That is their source leg. Source, yep, source legs snapped. It actually looks like they've been resoldered in the past. There's quite a big blobs of solder on the source legs there. It looks like they snapped in the past. Someone's just done a quick cheeky top board solder attempt, which obviously hasn't worked out too well in their favour. So we have some MOSFETs here, IRF 3415. Going to see what they are. First of all though, I'm going to remove all of those. Going to get these FETs off the board and see if the drive circuit is okay, see what that's saying. Devnala says Helix is like the best in terms of DSPs. Yeah, I would be probably willing to agree with you there. Helix makes some fantastic DSPs, and the user interface is really nice. Yeah, the usability of the Helix DSPs, I haven't found another DSP that's as friendly to use, like as easy to use, and just has a really nice, snappy, quick UI. You know, it's really, the Helix are really pleasant to use. Morgan says, "Sir Davids, what amps are left that are not just poor quality built in China?" I've kind of gone through it already. Powerus. Best amplifiers on the market at the moment for the money. Powerus. If you can get them, buy them. Other Brazilian brands that have my respect. Tyrant's Smart Series, really nice. Banda Viking, pretty decent amplifiers for the money. Yeah. So that's if you're looking for lots of power for good money. They're really good circuit designs. If you have some money to splash, then you look at JL Audio amplifiers, really nice circuit designs. You look at Rockford Fosgate amplifiers, fucking amazing circuit designs. If you're a little bit more budget incentivized, although their stuff is still fucking expensive, Alpine amplifiers are absolutely next level. Really nice amplifiers from Alpine. Bespoke in-house circuit designs. What else we got? We will see how the Digital Design's new M series turns out. Digital Designs have recently released a new series of amplifiers. They've released the M series, the M. Oh, fuck, I can't. I think it's the M2000. No, the M4000. No, yeah, the M2000, M4000, and M8000. I think. So I don't know if they're going to be any good yet, but they are sending me an M4000 to do a video on. So guys, subscribe to the channel if you want to see what the DD M series amplifiers are like. I don't know yet because I haven't got it, but we'll see. Sundown amplifiers, someone said. Not really. I wouldn't really suggest buying a Sundown amplifier at this point in time. Sundown make amazing subwoofers, and they make some pretty good component sets as well. But their current lineup of amplifiers, I don't really think is something that you should be spending your money on. I would look elsewhere. Is Sound Digital good? Sound Digital is great if you live in Brazil. If you are part of the Brazilian bass scene. If you're not part of the Brazilian audio scene, then Sound Digital is probably not going to give you what you need. Just because of what the amps are designed to do. Yeah, I'm not a massive fan of the Sound Digital circuit design. There's a lot to be desired. There's a lot that they could have done better. So I would probably not necessarily recommend Sound Digital. The Sundown Fullbridge, the SFB line of amplifiers, they are Sound Digitals. They are Chinese Sound Digital copies. So they are as bad as a Sound Digital, but possibly worse because they are Chinese copies. And I have had that experience repairing them. Old school Phoenix Gold Tantrum amps, the Class T, are pretty good when it comes to SQ. Peter B, yes. The Class T, the Tripath, is pretty amazing for combining the efficiency of Class D with a nicer sounding Class AB style sound. However, the Tantrum amplifiers, they're like the 1200.1, it's a mono amplifier. So most people are going to run a subwoofer on that, and a subwoofer doesn't fucking care about the sound quality. Like, it doesn't fucking care about how fast the switching frequency is or how many steps are used in creating the sine wave. It doesn't fucking give a shit. So don't use a Phoenix Gold Tantrum to run your sub, because it's a fucking waste. If you want to run some really loud door builds, yeah, then run one Phoenix Gold Tantrum per door. Now that will sound alright. Don't waste a tripath circuit on a fucking subwoofer, because it is a waste of circuit design. Because the subwoofer doesn't care. It's going to sound exactly the same as if you put it on a Torrens. Alright, so the outputs are out. Let's see if we have any switching on the drive circuit. It looks like I have actually stolen the grub screws for this one. I thought I probably would have stolen the grub screws for that. Actually, let's see if I have any grub screws that will fit in this one. Where's my grub screw set? I think I dropped it on the floor. Yep, fuck that. Can't be bothered. Let's just shove it in the holes. Powerless for larger door builds? No. Powerless amplifiers are fantastic, don't get me wrong, but they have a very, very low Class D switching frequency, which is great for subs, but it won't sound too nice on higher frequency stuff, on full range stuff. And also the filter circuit is not very existent, it's pretty non-existent for higher frequency stuff. So if you want to run loud, full range stuff, Class AB is still the best for that, but it's quite difficult to get a lot of power from Class AB. So if you're going to go Class D, then you want to go something really nice, not Brazilian. Unless you don't really care about how nice it sounds, you just want to get as loud as possible. Right, output section then. Let's see if the drive circuit works on this piece of shit Lanza Op 2000. Where are we? Here we are. Let's do trigger number 1. Low side. What the fuck? What the fuck? There's like literally no rail voltage. Eh? Right. There's our power supply. There's our power supply PWM, that's working fine. Here's our rectifiers. What the fuck? Oh no. Is that? No. Where's the rectifier? Hang on a minute. Right, rectifier, sorry, my bad. Rectifiers are over here. Rectifiers are over here. So that's our rectifier, that's our output from our transformer. Our rectified DC is there. Jesus Christ, that's noisy. Those rail caps can't be doing a good job. 44 volts plus minus. About 40 volts plus minus. But we don't. Here we go. We've got negative 40 volts. That's going to be the low side. Yep, low side. Okay, cool. So we've got the 1, 2, 3 low side FETs. Now the high side over here. Where the fuck is the positive rail? Nowhere to be seen. Positive rail is over here. Oh, got some vibration damage on the rectifiers as well by the looks of things. Like, that moves far too easily. Look at that. Alright, that is proper jumping around like a bitch. So I'm going to have to desolder and reattach these, I think, because they are definitely looking like they're coming off. Let's remove the voltage from these capacitors. Seems to have gone already. That was bloody quick, wasn't it? Oh yeah, look at that. There's fucking... what the fuck? There's literally no solder in that hole whatsoever. How has that happened? How has that happened, Lanzar? Where's the solder in there? Eh? Fucking hell. Fucking hell, mate. Alright then, let's get some solder in there. What I'm going to do is, when I'm soldering these legs, I'm actually going to pull on them with my tweezers to see whether the legs are actually like snapped or not. Because if they're snapped, obviously they'll pull out with the tweezers. Looks like we're missing the legs on the middle, actually, by the looks of it. Yep. Just gonna have to do a bit of cheeky soldering on there. I'm going to push these down lower to get the legs through the holes a bit. So I'm going to cook up all three legs and I'm going to push them down a bit. And the same on this one. They don't need to be as high as they were. Cook up all three legs, push them down in the board a little bit. That's it, there we go. And then I'm just going to suck the excess solder that I cooked up on there. Could you put Class H topology on a car amp? Yes, some brands have actually done that. You'll find Class H stuff in JBL crown amplifiers, and also, weirdly, I don't usually rate this brand, but Vibe. Vibe Audio is a UK kind of brand, and yeah, some of their amplifiers are Class H, Class GH, whereby it runs in Class AB up to a certain output level, and then it starts switching the rails and becomes a bit more like Class D. So it gives you the kind of Class AB sound at a lower volume, but then when you demand power, it can provide it without getting stupidly hot. So here, resoldered those rectifiers. Let's crack her back on and see what we have. Should have positive rail on these output legs now, these output pads. So what we got? Negative rail is there, negative 40, and oh yeah, there we go, positive rail. So I'm not seeing any switch waves. If I pulse the remote on and off, this is the negative gate. This is the low side gate. So if I crack her on, you'll see. If I remove the remote now, oh, a minute ago it was actually giving me some kind of PWM. Right. Negative 40. There we go. 33. There, 33. You see that jump? So that's the amplifier trying to turn on those FETs. So what I'm going to do now is I'm going to take some RCA signal and we're going to plug it into the amplifier, into the amplifier's inputs, and we're going to see if we can see any PWM. And what if I just switches the master, bass boost, low pass, subsonic, level, phase shift 0, yep, input, yep, okay. Looking good. So we're just going to shove. We're going to shove 50 hertz. About 50 hertz through it. See if we can see some 50 hertz on the scope on the low side gate. If we don't see any 50 hertz, then it could be the drive circuit is. Oh, there we go. Yeah, that looks right. I think that's going to work. I think that might work, you know. Also got some PWM on the high side, which you don't always see. Pretty cool. I think, Carlson, that might actually fucking work. Which is cool, because like I said earlier, if these drive circuits give up, then you might as well fucking give up. What is the rail voltage actually? Because I'm going to choose some new FETs for this from my stash of spare parts. So if we have a look at the rail voltage, we have with a 10 volts worth of input, we have, what is that, 39 volts plus and minus. So yeah, it's about 40 volts plus minus. So what I want to do is we want to go up to the maximum amount of voltage that this amplifier is ever going to be given with. So if we go all the way up to, like, I don't know, 15 volts, 16 volts, whatever. Yeah, there we go. So we've got 52 volts. So we can get away with 150 volt MOSFETs because we've got plus minus 100 volts worth of rails, bit of headroom, 150 volt parts. So let's see what we got in my spares drawer. Oh, we've got some bloody powerful parts in here, lads. Got some IRFB 4321s. That's a bit overkill. I don't think the drive circuit will handle those too well. 46 N15s. This is only a 1000 watt amplifier. We don't need anything crazy. Let's get rid of the bigger parts here. So in this tray we've just got some 640Ns, 200 volt parts. No, maybe I want some 150s. 640N. Okay, I don't think this is the right tray. Let's try something else, shall we? 150 volt 220, here we go, that's a bit more like it. Got 33N15, that might work. From memory, these amps usually use IRFB something or other. 075N15, that's from Atar amps. Here we go. 3710Z, that might be the kind of thing that's going to be in this amplifier. See, there we go. 3710s, that's the kind of thing that you're more likely to see in these amps. I do need to double check that those are 150 volt FETs, so they might be 100 volt FETs. Hang on a minute. IRF 3710, let's just do a cheeky Google search, see what they are. Might be 100 volts. Yeah, okay, so they're a bit excuse me, they're a bit too low, so we can't use those. We want to use 150 volts, so I'm thinking 33N15s are going to be the way to go. Got a few spares of those. Remember, lads, this is not a customer repair. This is just some bullshit piece of crap amplifier that I have had sitting around on the back burner for many years. I have never bothered to repair because I couldn't be bothered. So here we are, just see if we can get it back up and running. We've got some 46N15s. They might be good. They're a bit high power for this, but if I can find them quicker, then we'll throw them in. Yep, I think it's going to be 46N15s, lads. Although, you never know, I am finding quite a lot of these 3315s. Want to make sure that they're all the same batch, of course. Right, I think that will probably do. Got quite a lot of these 46N15, so I think we're going to roll with those. We're going to see how the circuit likes those. Just going to make sure I've got enough of them to have matching batches for the whole amp. Because the more of them I've got, the more likelihood is that I find matching batches. Yeah. Right, okay. There we go. Yeah, so mostly 46N15s. So now I just need to quickly whack them into their batches. And we got 336AB. Couple of different batches here. I need what do I need? 1, 2, 3. I need 6. I need 6. I've got 6 already here that are the same batch. So once I've found like quite a few of the same batch, I'm just going to whack them through my transistor tester, make sure that the VT is the same, make sure that we've got relatively matching VT readings on all of these. So yep, here we go. We've got a bunch of these FETs that are matching now. So let's grab our transistor tester and find 6 that have the same VT. Very important. VT is the one you want to match. So 3.2, let's start making these up. We need 6 that are the same. 3.2, RDS of 0.2, 3.3, slightly higher, so I'm going to put that one above. 3.5, that one's way higher, so that wouldn't be so comfortable running with that 3.2, so it's important to check for this. 3.2. That's good. Got a few 3.2s. Looks like that might be the baseline. .4. It's a bit high. 3.2. Nice. Lovely jabbly. Come on, give me 2 more 3.2s and then we're good to go. Peter says the best FETs for that amp are the 31N20. That's a bit high. I mean, the rails with a 16 volt input are only capping out at about 50-ish, 56-ish volts. That's a bit high. So using 200 volt FETs is probably a little bit overkill. If I've got some of those, I could put those in. I want to see how these 46N15s do. .4, that's a bit high. Come on, I need 2 more 3.2s. Fucking 3.4. Yay, 3.2. This is the last one, so hopefully that's a 3.2 as well. .2, there we go, there's 6 3.2s. Peter B says no, they work for the drive circuit. I know that these drive circuits are very fussy, but I am tempted to try this matching 6 set of 46N15s. But just out of curiosity, because I have noticed that these kind of circuits do often use the 31N20s, albeit in slightly bigger amplifiers with a higher rail voltage that will take better use of that headroom of rail voltage. Let's see what the specs are. Let's see how some of these 31N20s read on the meter, because obviously, so these 46N15s, they will present the drive circuit, each FET, with the turn on voltage will be 3.2 as we just shown, but the gate capacitance is important. So each MOSFET will present a gate capacitance of 2.41 nanofarads. So with 3 MOSFETs in parallel, each side of the drive circuit will receive about 246, about sort of 7 or 8 nanofarads worth of gate capacitance. So if the 31N20s are similar to that, then we should be fine to go with, oh, here you go, here's a 34N20. I wonder what that is. I know that they're going to be probably quite different. I'm just curious to see what a 34N20 is. So that's double the gate capacitance there. Fair bit higher VT as well. Now what is the gate capacitance of the 31N20? Let's have it. Here we go. I think here's a 31N20. So let's have a look and see what is the gate capacitance of a 31N20. Okay, now in this case, I knew this was going to happen with the bloody 31N20s. The gate turn on voltage is too high for the tester. So the tester only uses a VCC voltage of 5 volts, which isn't high enough for it to turn on the gate of this 31N20. So I can't actually check and match these up by VT with the 31N20s because the gate turn on threshold is just too high. So I don't even know if I have 6 31N20s anyway laying around. So just for shits and giggles, let's load up the 6 46N15s. Let's see how they do. Let's see how they do. The legs are all very bent on these and shit. Like the legs are all massively mangled up on these ones. I have to sort of straighten them out a bit and get rid of some of the excess solder on them. Sir and Attengate, I wish I could send more your way. Dude, thanks massively for the 5. That's a massive appreciation of that. You deserve much more for how much you have helped myself and the community with your work and knowledge. Keep it up, man. Thank you so much for your kind donation there, my man. I'm glad that, you know, the bullshit that I chat about on the stream is somewhat useful to you. So yeah, thanks for that. What do you think about quarter wave transmission line boxes such as Steve Me Designs site talks about? Richie, I actually have a quarter wave transmission line. I actually have 2 quarter wave transmission line boxes on my door cards. Yep, my door cards, my front doors, are quarter wave transmission line boxes. I know a thing or two about T-lines. Is it possible for you to increase the power output of a monoblock amp? Well, my friend, if you subscribe to the channel, you will see me do exactly that. Because I'm currently working on a power increase modification to an audio pipe 3K. 3K in inverted commas, because it's not actually 3K. But it will be, when I'm finished with it, it will be absolutely ridiculous. Guys, who wants to see a little sneak peek of the progress I'm making with the audio pipe? The audio pipe mod. I'm sure most of you are aware of that, what I'm doing with that. A little collaboration with Big D Wiz. Derek Wilson Audio Channel, now whatever he calls it. I'll give you a sneak peek of what we've been working on. Very, very interesting shit, I have to say. Getting rid of all the old solder on these legs. There's loads and loads of solder on these legs of these FETs. Just got to get rid of all that shit before we can put them in. There it is. Yeah, man. Sweet. Alright, guys. Yeah, if you stick around after I have just whacked these FETs in and seen what happens, I'll show you where I'm at with the audio pipe mod. It's freaking awesome, what we're doing so far. So I'm probably like I'm probably a little way off of actually getting the amp playing into high power, but not as far off as I think. There were some very interesting and exciting kind of like educational hurdles to overcome in modifying the amplifier to do more power. It wasn't just as simple as I thought it was going to be, like shoving more rail voltage up its ass. It wasn't that simple, but what made it not that simple was really interesting and really awesome, like mod stuff. Go on, it's always the last one. There we go. There it is. There it is. So what do you think, guys? Do you think this is going to work? I don't know if this is going to work. I'm not sure if these FETs are going to present the circuit with enough gate capacitance, because I've got a feeling those 31N20s that my man in the chat says these drive circuits are generally kind of designed for, I think the gate capacitance of those bad boys is quite high. So I don't know if because the way that this drive circuit works is very dependent on gate capacitance in order to work. So if there isn't sufficient gate capacitance, then it might not actually oscillate properly, and we might have problems. I'm just soldering one leg quickly to the bottom so they don't fall out, so I can flip the board over. Just to set the height of them. So now I can flip the board over and solder the rest of them without risk of them falling out. Alright then, there we go, all soldered in. Last check before we power it up is make sure that we have gate continuity across here. Let's flip it back over for a sec. Alright. So take the old multimeter, make sure that none of the gate resistors are dead. We're going to take our multimeter on legs pin 1, and we have pretty high value gates on this actually. We have what looks to be 100, I think we're going to have 100 ohm gates roughly thereabouts, 97. So we should have about 200-ish between FETs, so 194, 194, 194, and 194. Yeah, so all the gate resistors are intact. Okay. Yeah, good. So now let's power it up and see if the drive circuit likes these FETs or not. It might not do, because there might not be enough gate capacitance, but we can only try, can't we? Okay, 10 volts worth of inputs. Okay, oscilloscope probe on low side drain, like that. Oscilloscope screen, and let's see what happens. Will it pop? Okay, no oscillation yet. Oh, it's trying, it's trying, it's trying. It's trying really hard. Increase the voltage a little bit. 11 volts, 12 volts. So from experience in the past, when you have that, the circuit is trying to oscillate, and there's two things that you can do to help it. Firstly is attach a load to the speaker terminals. So right now we're just going to attach a quick load, 16 ohm load to the speaker terminals. That can help it kick into operation. If that doesn't work, then you can kickstart it with some RCA signal. some amplifiers just work like that. Literally, they require a little bit of kickstart to get self-oscillation built, even from factory, especially these cheap shit circuits. But where I haven't got as much gate capacitance as maybe the circuit needs to sort of start self-oscillation by itself, we might just need to kickstart it to kind of get it into operation. So I'm going to remove the RCA actually. I'm going to try just a 16 ohm load on the terminals to see first whether that gets it up and running. It's trying. Okay, so the load didn't help. Oh, did you see it? Just at the last minute there, just before I took my foot off the remote, there was some switching. So I'm going to remove the load. I'm going to apply my RCA signal, and I only need a very, very tiny amount of signal, very, very small amount of signal. So I'm just going to go ahead and turn my signal down a touch, minus 20 dB, 50 hertz, and let's try that again with a little bit of signal to kickstart it. Ta-da! There we go. Ah, that's lovely. A nice low idle current draw, 1.1 amps. So now that we have kick-started self-oscillation, I can remove the RCA, and that will maintain switching. So if I increase the voltage up here to 12 volts, yep, got a 52 volt RMS switching wave. Looks pretty nice. And yeah, the fact that we kick-started that with some audio shows that it's going to work with audio. So if I plug the RCA back in, and there we go, there's class D modulation, so that's producing a sine wave on the speaker terminals. So yeah, that's all fixed. Nice, good job. Good job. It didn't mind. It was quite happy with the 46N15s, and from my experience with these circuits, even with the factory FETs, a lot of the time these ones do need just that tiny bit of signal to kickstart the Class D oscillation there. It's just the same case with the base phase plate amplifiers. They use the same drive circuit. Yeah. So now that's all out of the way, let's give you a sneak peek at the audio pipe. What's the deal with the audio pipe here? Okay, what I'm going to do is, just before we go, how many viewers have we got? How many viewers have we got now? 115, not that many. Okay. Okay. What I think the best thing to show you, the best way to show you this is probably to... I have actually uploaded the first 12 minutes of part 2 just to show to Derek and to just as kind of a bit of progress. So I'm just going to go to my YouTube right now. It's unlisted video, and just kind of show this a little bit. Do I have desktop audio? It's muted. So guys, what I'm going to do is I'm just going to mute this. I'm going to show you the web. I'm just going to mute this video here. So this is the audio pipe second modification video. So from part 1, what we've done is we have done a very temporary wind, done like a temporary test wind on the Banda transformer, okay, just to make sure that the core is happy in this circuit. And then ran some test leads off to the side of the audio pipe, which just made it easier to kind of make ongoing changes to the wind ratio, so I didn't have to keep soldering and desoldering it from the board. Looks a bit messy, but it's actually really, really handy. Then tried to power the amp up and found that it would go into high voltage protection, because obviously the amplifier is expecting a certain rail voltage, but it's receiving much higher, and the PIC actually listens to the voltage on the rails. So therefore it went into protect, so I had to modify the protection circuit first. There we go, there's like a little diagram of how that works. So I had to modify that first, found the rail voltage sense resistors, and was able to then apply a potentiometer to that to trick the amp into thinking that it had a much lower rail voltage than it actually did. So there's a little potentiometer, and I can put that in series with those sense resistors and adjust the resistance to trick the PIC into thinking that there's less rail voltage, and the amplifier powered up, which was cool. Nice high rail voltage. Then as I increased the rail voltage, I noticed something very interesting. So this is the output switch wave, okay, of the audio pipe. Now notice, as I increase the voltage from 10.6 volts up, the rail voltage down here, 63 volts currently, increases. But as that increases, look at the shape of this output switch wave. It's really thin, and it gets thinner the higher you go. And that's the duty cycle. So see how the duty cycle starts off at 37%, which is a bit low anyway. And as we go up, we see it reduces. Like the switch wave gets really thin, and it's down at 28.9% duty cycle. And basically that's a problem. That's actually a feature that the circuit designers implemented into this design of circuit to limit the amount of power that this amplifier creates with a high rail voltage. So these amplifiers are designed to do their power at 12 volts, and when you shove 14 volts through their ass, instead of doing more power linearly based on square law correction factor with a higher voltage, they're actually designed to sandbag the amount of power they make at 14 volts in favour of sort of more optimal operation at 12 volts. So the way they do that is that as you increase the rail voltage, as you increase the input voltage, rail voltage increases, lowering the duty cycle of the output PWM switch wave, which actually massively sandbags the amount of power that this amplifier can produce without clipping. So I actually go into this in quite a lot of detail into how this works, and how the duty cycle being different will cause the amplifier to clip at different levels. With a lower duty cycle, you'll find that the amplifier will clip at the bottom first. I talk about why Triumphs have done this and how the floating midpoint changes because this is a single rail amplifier. So yeah, I go into a bunch of really in-depth information about exactly how this. Oh fuck! I just realised I wasn't actually showing you the screen. Let me go back. So anyway, so yeah, like I was saying, this is 50% duty cycle. This is like a Korean amplifier, showing you that's what it should be. I go into a bunch of detail about how the modulation works in creating a sine wave, and how having a different duty cycle for it to oscillate around will cause clipping too early, or at the bottom of the sine wave or at the top of the sine wave too early. And I explain how a variance in duty cycle will affect the floating midpoint of the amplifier. The sine wave oscillates around. As you can see there, it changes with the varying duty cycle, clipping at the bottom or top first. And I try to explain why Triumphs have done this. It's to sandbag the amount of power that this amplifier can make at 14 volts, or whether it was to compensate for rail voltage sag under load to bring the clipping equal again when it was loaded. But then I went back on that and I was like, no, that can't be the case because blah blah blah, a bunch of reasons. So that was interesting to figure out. Something that I had to change. Like, I couldn't just leave that, because the whole idea of making this amplifier more powerful is shoving more rail voltage up his ass, and if by shoving more rail voltage up his ass we're going to end up with really really low duty cycle, it's not going to make any power. It's just going to be shit. So I had to modify the circuit. I had to this was a big massive thing. Took me ages to figure out what to do to modify the circuit to actually allow there to be a more sensible 50% duty cycle with a higher rail voltage. And it involved looking at the example schematic for the 2092 drive IC, which this amplifier uses, and finally figuring out which parts of the feedback circuit are responsible for setting the duty cycle based on rail voltage level, finding out some more shit about the audio pipe and how it was designed differently, and then finally figuring out which parts are responsible for setting the duty cycle. And you can see that I'm manually varying the duty cycle with a potentiometer, and therefore varying the floating midpoint the sine wave oscillates between. You can see that I'm changing where the sine wave sits between ground and rail. That's fucking awesome. So the change in duty cycle changes where the sine wave sits. Like, yeah, it's fucking all like, oh, that's so satisfying to me as a amplifier repair nerd. Like, seeing that is so fucking sick, man. That is wicked. That's just so nice. And I was like so happy that I found it because it took me fucking hours to find it. So I was like, yes. So that's where I am at the moment with the amplifier mod. So I've overcome the protection circuits. I've overcome the drive circuit limitations that will prevent me from, you know, getting decent power from the amplifier now. I've ordered the components. I've ordered the new higher power parts for this amplifier. New output MOSFETs, new power supply MOSFETs, rectifiers, stuff like that for this amplifier to make stupid amounts of power. And the only thing now I need left to do is to order the right amount of Litz wire. Once I've decided how much rail voltage I actually want in this thing, is to order the right amount of Litz wire for the transformer. And once I've done that, then it will be fitting the new parts, squeezing them into the fucking heatsink. Also, I have a shitload and more rail capacitors I'm going to put in there as well. Filter capacitors, fans, and what else was it? I need to test it thoroughly, right? I'm in the UK. Derek is in the States. Once I've done this modification, okay, I need to test it fucking hard, because if I complete the mod and I send it to Derek and it blows up on his dyno, that's a waste. Like, that's so shit, because he can't just easily send it back to me to repair and like make other changes to, because it costs so much money every time we ship it to the UK. So it's got to be perfect. I've got to modify it, I've got to test it thoroughly. So I can't go too stupid with how much power I want out of this thing, because if I go too stupid with it, then the chances of it blowing up on his dyno are quite high. So I need to go high enough that it's impressive, but low enough that it's safe, that it's likely to work and make a good video for him, and to be cool and to do lots of power, you know, for a good video, so it doesn't blow up. So that's the kind of point I'm at now, is deciding how far do I go, how much power do I demand from this thing to make it impressive, and a cool amount of extra power, but also sensible and safe, so that the video actually works and the collaboration actually works. So that's the kind of point where I'm at now, just deciding how much power I want from it. But I have already ordered the FETs and stuff like that, so I do have a limit, a physical limit on the parts I've ordered, but that limit is quite high. So I could, in theory, be asking for like 8,000 watts or more from this board now. This audio pipe that started off doing like 2,300 watts. Yeah, if I shove the right amount of rail on it that it can currently handle, and that the circuit will handle, the parts I've ordered will handle, we could be seeing 8,000 watts from this thing. Whether it will survive on the dyno, I don't know, but that's yet to be seen. Mike Honor says, I remember the transformer was the issue. Did you get through that part? Yes, that was my bad. I stupidly wound one of the primaries like backwards. Like, I didn't realise that it mattered which way around the transformer core you wound it, but it does. So again, that's just me learning about transformers. Transformers are, like I said in part 1, a weak part for me, weak point. Not massively clued up on transformer design, but now I'm a bit more clued up. So now I'm past that hurdle, so that's all cool. And now we're moving on. But yeah, it's going to be fucking awesome. I'm well excited. I've got so many plans for things to do with that audio pipe amplifier before it goes back to Derek. I'm going to wire it up in my van. We're going to like do some hair tricks on the 215 Z4s with this tiny little audio pipe pushing ridiculous amounts of power. It's going to be really cool content. I think it's going to be mind-blowing. Like, seeing this tiny little amplifier on the back of my wall wired up with these massive reducers into like 70mm welding cable, and then like fully hair tricking, it's going to be pretty awesome. And in my van it'll be running at 0.5 as well. So if I boost this amplifier to the point where it's capable of making around about 8,000 watts at 1 ohm, well, at 0.5 the amplifier is going to behave like a 16k. It won't make 16k, but after rise it's going to behave like a 16k. And I explain this to people a lot when they ask about running at 0.5 and stuff like that. like, yeah, if you've got a 5,000 watt RMS amplifier running at 1 ohm, wired to 1 ohm, but you're rising to 2 ohms, yeah, then you're only getting like 2.5k out of that amplifier. If you wire a 2.5k amplifier to 0.5 and you're rising from 0.5 to 1 ohm, you're getting 2.5k. So that 2.5k amplifier is behaving and will sound exactly the same as your 5k amplifier. The 2.5k amplifier isn't making 5k, it's making 2.5k, because it's making it after impedance rise at 1 ohm, whereas the 5k, it can't make the 5k that it's rated for because of impedance rise. So when people ask about running at 0.5, if you on paper you double the power, it won't make that power, but it doesn't need to behave like a much bigger amplifier. So yeah, running an 8k amplifier at 0.5, provided your impedance rise will bring it back over 1 ohm. If you wire it at 0.5, it's going to pretty much sound similar to running a 16k at 1 ohm. So yeah, it's going to be so fucking sick. I can't wait. I'm so gassed. The parts for this amp mod are so expensive. I spent so much fucking money on the parts for this amp. Like, each MOSFET was like 12 quid or something like that. Like, if it blows up, it's going to cost me a shitload of money. But it's all in the fun of science and shit. So yeah, hopefully the video will get lots of views and get some YouTube monetization to help me out with the finances of that amp mod, because it's pretty expensive parts, but it's going to be so sick when it's finished. The only issue I'm going to have with it is I'm limited by the heatsink. Yeah, that audio pipe heatsink is fucking tiny. So if I like, the amplifier might be capable of doing 8k, right? But to do that for long durations, that heatsink is going to cook up. It can't get rid of that much thermal energy quick enough. So we're going to have to add some external fans, or it's going to be a burp amp only kind of thing. You can daily it at like 3k, but the 8k is burp only, because otherwise this is going to get too hot because it hasn't got a heatsink to do that. So yeah, the physical limitations are there, but that doesn't mean that we can't get ridiculous numbers on the dyno from it. So I can't say your name, straight up kinky and at Aid Nuts or whatever your name is. When I was looking at replacement parts for this, I didn't filter by package type. I had some specific specifications that I needed the parts to meet in terms of voltage limit, in terms of RDS, in terms of size to fit in the heatsink, and the parts that came back were of a specific package style. I didn't tell when I was searching for parts. I didn't filter by a specific package style. I just let the website show me MOSFETs from all different package types that fitted within my range of specs I needed. And those ones that you said about LF Pack 88 weren't one of them that it showed me. So maybe there weren't any that fitted in the specs that I needed for that mod. What MOSFET are you going to use on modification? Let's have a quick look before I go to bed. Let's have a quick little look and see if I can find out. Oh shit, my Gmail doesn't work on this. Hang on a minute, lads. Bear with me a minute. I'll see if I can tell you what FETs I'm using. Fucking hell. 2-part verification bullshit. Yes, it's me. I log in from this PC every freaking day, you dickhead. Right, where did I order them from? Was it RX Components, or was it Farnell, or was it Mercatio? I think it was Mercatio. Okay. 415s. Here we go. Here we go. This is what. Is it what I ordered? 400 volt, 15 amp. Oh, that's the rectifiers, isn't it? Yeah, okay. That was on 3 days ago. I'm just going to quickly look at my invoice. Excuse my nasal issues. I have the mad hay fevers. Here we go. Okay, found it. I was just making sure there wasn't any personal information in there. I'm just going to use a snipping tool to snippety snip that part of the email and then minimize, and then take a quick look at this one here. Okay, our screen. There we go. So hopefully you can see this. This is the parts that I've ordered. As you can see, the total came to £90. Not too bad, but still a fair amount for just this little modification I'm doing. So the output MOSFETs are a plus 247 package. They only just about fit. They're massive. And the reason I did that is I wanted maximum thermal transfer to the heatsink for these. So these are IXF 150N30Ps. So these are 150 amp, 300 volt parts. And I checked the gate capacitance and all that stuff wasn't too high, and also the drive circuit, the 2092s, are actually capable of running pretty mad amount of FETs. You know, they're pretty good at driving FETs, big powerful FETs like this. So that should be pretty alright. But we'll see how it goes. If they don't work, then I'll have to buy some more. Rectifiers, bought some MUR 1540Gs. Bought 4 of those. The amp only uses 2 rectifiers normally. However, I bought 4 rectifiers. These are single diode rectifiers, and I'm going to have to join the legs together to create the common anode and common cathode rectifiers that I need, which will give me more thermal transfer because you've got 1 diode per TO220 package instead of 2. Power supply MOSFETs went for 247 AC package ones instead of the standard 220s, which are in the amp at the moment. Only just about fit. Again, gonna have to come up with some custom heatsink method, mounting methods. But yeah, these are the IRFP 4730 PBFs. Loads more rail capacitors. Again, you can see 3 different types of rail caps, and I had to order all different sizes to get them to fit. I wanted to absolutely squeeze as many rail caps as I physically could into that heatsink, so I had to order a few different sizes to sort of fit them in different locations. But yeah, that's the output FETs, the rectifiers, power supply FETs, and capacitors. And that's all the parts I've ordered so far. What else do I know? I'm going to need some fans. Definitely going to need some fans. Going to need some pretty goddamn good thermal paste and thermal transfer tape stuff, which I've actually ordered separately. That was quite expensive as well. And we're going to have to thicken up the traces. Water cool the amp. Yeah, I could do, but then the amp's not really like. I want the amp to look. I want it to be like sleeper. You know, I want it to look completely standard. Like it just is the amp. Like I don't really want fucking big fans hanging off it and water cooling shit like connected to it, and that gets really complicated and there's loads more chance of failure. Like I want it to look standard, and yeah, or it might not be able to do the full power for long durations without overheating. But that's fine. For the purposes of this video, the idea is just that it makes a fucking big number on the dyno, and that's it. Thanks for the 5, Thomas. What's up? How's it going, man? Cheers for that. What about changing the output filter caps? I looked at those and they are 450 volt rated caps, so they should be fine. But I'll do plenty of testing, like fucking loads of testing, before it goes back to Derek to make sure that there aren't any parts that are going to fail prematurely. So once I have fitted all the new FETs and chosen my high rail voltage, I'll be running the amplifier in my van you know, making sure that it is stable, making sure that none of the filter caps pop or nothing overheats and all that shit, and going from there. Thanks for the 5, Mickey. Appreciate that, man. Thanks for that. Anyway, guys, I think it's about that time. Almost 2 AM in the UK here, and I hope we have had fun this evening on tonight's stream. I've had an absolute blast. I've missed doing this. It's great fun. Missed chatting to you guys. And yeah, we repaired some really crappy piece of crap amps that I had on the back burner, so I can now do absolutely nothing with them. I can sell this Lanzor actually, because this is a full amplifier. I have all the bits for it, but the power acoustic, I'm missing all the end plates, so I can't really sell that. So I just have to keep that as a test board for something or other. I don't know what I can do with that. But anyway, good stream nonetheless. Hopefully you learned something. Hopefully you were entertained. Hopefully there was some good info flying around. I had fun. The 2092 doesn't have a buffer. Godfrey, no. If not, you should put a small heatsink on the 2092. That is a good idea. I do actually have some small heatsinks for that style of chip, so that is not a bad idea. We'll definitely be doing that. Is that the sound digital amps use to drive? Like, they use a single fucking tiny driver, fucking tiny thing to drive like 30 power supply MOSFETs, and they get hot. Those drivers get hot. So I bought some heatsinks for those. So I do have some that I can use. That's a good idea. Thanks for that. Yeah, nice one, guys. I'll catch you in the next one, and the next live stream hopefully won't be too far away. I reckon next week I'm away from home. So I reckon about a couple of weeks time, get another stream locked in, and I should have some progress on the audio pipe mod as well. I want to get that video up and running as soon as possible. I might release the part 2 video. Like I was originally going to just make it one video, but then I realised it was going to be about 3 hours long. So I did part 1. I was thinking I might be able to finish it in part 2, but now looking at part 2, it's going to be long. So I might just do some more mods on part 2. And then leave it at that, render it, upload it, and then part 3 will be finishing the mod and testing it. Actually, part 3 will be finishing the mod and getting the amplifier to its finished state. Then there'll be a 4th video which will be demos, which will be like abusing the fuck out of the amp before it goes back to Derek. So I think it'll be like a 4-part video, 3 parts of mods, and then the final 4th video will be like demos, and then it will go back to Derek. But yeah, peace out, guys. Thanks for joining.